Hello, 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 and we are back for more Advent of Code. That is day 9. There is just 4 more days left. Alright, let me my to-do thing. Bum, 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 ba-da-dum. Hello, Nigel.
Hello, Betseg.
Hello, Betseg. Hello, guys. Alright. Do we start immediately? Do we wait a little bit?
Hello, J0 Han Anderson.
Hello, J0 Han Anderson. Hi. Do we wait for something? Well, I mean, so yesterday I was trying to profile. Yesterday, if you guys were not here at the end of the stream, my stream crashed. I mean, not my stream. My stream did not crash. My Linux stopped working at all. I had like a disk issue or something. So hopefully that doesn't happen today. I never had that happen before. So yeah, start immediately because today will take a hot second. Okay, it's actually a difficult day today. All right, let's just not waste any time. All right. I just wanted to like say that I implemented the profiling of the actual language itself, like in some way. So I implemented the Chrome trace format because that's what ChatGPT suggested I should do, right? And we can use this to load it into the tools that actually can show me my profiling data. So we can have this trace file, trace JSON, and this is what it looks like. So we see everything like, so this over here, right, is basically so this is the entire like solution for day 8 of the Advent of Code, right? It seems like there's 3 stages here, right? And we see like every line of code basically, how long it took to execute it. Not exactly like every line of code. I do it for every like function call. Should do it differently, but like basically it's very easy to generate this thing, and then we can like select the ranges and look at the flame graph here and see what actually is the thing that took the most time. That's like very useful. Milk bad. Is milk bad because I was opening this thing? Because like it's actually lagging here. Because I have a lot of data, I suppose. It's good now, though, right? All right. Okay, fine. Let's start. It's going to take some time, they said. Some of the tiles are red. Elves here, okay, the movie theater has a big tile floor with an interesting pattern. Elves here are redecorating the theater by switching out some of the square tiles in the big grid they form. Some of the tiles are red. The elves would like to find the largest rectangle that uses red tiles for 2 of its opposite corners. They even have a list where the red tiles are located in the grid. Your puzzle input, okay, that makes sense. So this puzzle input corresponds to this thing, and I need to like find the pair that gives us the biggest area. That sounds really easy, right? That sounds really easy. Like if we can do it with square complexity at least, right? Of the amount of the thing. So like it depends on the size of the input here. Look at the Advent of Code start. Part 1 was 3 minutes. Part 2 was 8 hours. I see. Okay, so part 1 is really simple. I see. So let's just get done with it quickly and then see what's wrong with part 2. New folder, day 9. Example. this. Copy main. I guess as in 64 will probably be useful. J9. Like that. Okay. Let's see. First, we need to like figure out all the coordinates, right? So I need to have the type coordinates of the tile, right? It's x and y. Let me actually first take a look at the input. This doesn't look like there's a lot of lines here. It seems like it's even less than 1,000. A9 input txt. It's less than 1,000. It's just 500 lines. Okay. All right, and then also the numbers themselves is another interesting part because we need the what is it called, like the area, right? The largest area. So the area is like quadratic over the coordinates, which are 10 to the power of 5, which means that we can get 10 to the power of 10, which is out of int64. Out of int32, so we need to use int64s actually, right? So let's do that immediately. We have x, we have y. Yeah. So I guess we call them red tiles, right? Red tiles. This is going to be a list of coordinates. Create the list, lines of input, line, if string length line is not 0, then x and y is string split once in comma, right? And then we say that x is x bars, y is y bars, chords is x and y, push back to red tiles, chords. Hello, normally never actually watch your streams. Today's part 2 was fun. Scrapped my algorithm half an hour in. Well, welcome to the stream. Welcome. It's lines, not line. Alright, so we do this. This is just our stuff, right? Our input, and then we just go for I in 0 to n, where n is list length of the red tiles. I don't like the name red tiles. That's the lore though, right? They just call it tiles or whatever. Is your next game gonna be in cast? I mean, that's the plan, yes. But I will probably do some other things before making games. I will be, I don't know, we'll start with like the Twitch bot written in cast. The language itself, we need to like self-host it, I think, before working on it more, because I hate OCaml. And like maybe some other things too. What else would make sense? Like the Twitch bot, self-hosting, Discord bot. Do I hate OCaml? I mean, I don't hate it too much, but I mean, it's just it gets in my way very, very often. The tooling, the LSP sucks. The the recursive, like when you want to do some recursive structures, it's a big pain because like recursive functors in OCaml make me just repeat myself too much. I hate repeating myself. And also it makes me write everything in one file, and I hate writing things in one file. You know. So like if you can actually like structure your program in a way that's not like recursive, right? Like actually split the dependencies properly, right? But it's not always possible. This is a good one. You mean like the day? How long did it took you to do it? I heard it's difficult. I'm just in part 1 for now. Part 1 should be easy. Can you just concatenate the files in the build process? I get the LSP wouldn't understand that though. Well, I mean, maybe there's the preprocessors, right? Yeah, I don't think the LSP would understand that. But I mean, LSP already sucks, and if you do something fancy with it, it's going to be even worse. So yeah, I don't know. It's not very enjoyable, in my opinion, writing code in OCaml. If you just do something small, like solving the advent of code in OCaml, you are going to not notice a lot of the issues that I'm having when I'm working on my language, though, and you might like it. I don't know. A lot of people still like OCaml. If like a lot of people, like still like OCaml, right? It's just I who have the problem with every language that I use. It took a long time to run, so maybe 4 hours working on it. I see. Okay, IJ, we do this. We say A is... You think it will be easy for me? We'll see. I don't even know the statement yet. Like, what's the problem there? The part 1 seems really easy. So we say A is list at tiles I, B at J. What didn't you give to it? Just the area itself, right? So we say that area is so I need to like the absolute, right? And absolute of b dot x minus a dot x times absolute b y minus a dot y. Kuviman knows all the algorithms. Is it not fair? I don't even know all the algorithms. I guess a lot of the current tooling is downstream from Jane Street, or maybe not. I don't know. I just used the tool from the Jane Street the other day, called like the memtrace for profiling my memory leak, and like I was trying to profile my memory leak, and like just installing that thing, I needed to do I need to like change the source code a little bit because they didn't even like do the dependency. I don't know. I feel like I don't know. I'm just using it in a different way, maybe like OCaml than other people somehow, that other people don't have problems. I borrow check, hello. I borrow check, do you have problems with OCaml? You use it to make your own language too, right? So, am I the only one who actually doesn't like it? I mean, I'm still using it, right? So it's better than the alternatives, I guess. It's just like, you know, you have problems with OCaml too, especially monads. Yeah. Can try it side let track, etc. Yeah. I use like the let star and stuff, like the monadic things. I hate it. I hate it. I feel like it's better if I don't use like this like special like monadic things that they introduced. It makes the code really unreadable, I think. What's a monad? I'll let somebody else answer that question. So absolute is a function that takes x and returns if x is less than 0 than negative x. I cannot do negative x, by the way, and also 0 is and in 32 I need to, yeah, I have this problem right now. Let's say 0 is 0 is as in 64 0 for now. Save a little bit. Then, and I don't have the unary minus. Maybe that's like whatever. Let's solve this thing first and then improve the language, right? That makes sense. So I do 0 minus x instead of just x. There you go. And then answer is 0, but if area is more than answer, then answer is area, right? Like this, dbg print answer. Day 9. Okay, 36. 50. That's not correct because like this is including, so we need to add here +1. So we have the absolute, and then after, and I need to add 1 here. I need to add 1. Let's have to do make language easier to use in 64 literals, and over here to do unary operator. 1 is as in 64 1. Okay, 50. Now we go to the input txt. Well, I guess it still is pretty slow even to do that. Well, I mean, it's 500, yeah. Yeah, my interpreter is slow. Unary negative is worth, unary plus is useless. You think so? I think unary plus is nice just for readability. I like it just like so that like it's obviously it's useless. Semantically it doesn't have any meaning, right? But it's for readability. I like it being there. Okay, part 1 is solved. If your part 1 is this slow, you're gonna wait a while for part 2. We'll see. I mean, yesterday for day, this is day 9, right? Day 8, I was waiting for a couple minutes for my thing to run, right? Even although it's supposed to be pretty fast. Please make chaining unary plus an error. Yeah. I mean, it will, yeah, it's just like we just make it to be not associative, right? No associativity on the unary operators. It must have something of lower priority, and like plus minus should also not be possible, right? Yeah. I mean, I can like change some things in the interpreter to make it faster, like, but we'll need to like see what actually needs to be improved there. Day 9, part 1. All right, here's the actual interesting part, right? What is part 2? Let's see. Where do I go? Over here. The else, just remember, they can only switch out tiles that are red or green. So your rectangle can only include red or green tiles. What is green tile? In your list, every red tile is connected to the red tile before and after by a straight line of green tiles. Okay. Sure. The list trap, so the first red tile is also connected to the last. Tiles are adjacent in your list, will always be on either the same row or the same column. Nice. Using the same example as before, the tiles marked X would be green. In addition, all of the tiles inside this loop of red and green tiles are also green. So in this example, there are green tiles. Okay. Can it be that the path intersects itself, though, in the actual input? In addition, all the tiles inside this loop of green and red tiles are also green. So this is also all green. Okay, that makes sense. The remaining tiles are never red nor green. Neither, instead of nether. The rectangle you choose must still have red tiles in opposite corners, but any other tiles it includes must now be red or green. This significantly limits your options. Yeah, that makes sense. It will not intersect, thankfully. Okay, it doesn't like say this here, but yeah. Okay. No, that's yeah. Sure. So we just have like a polygon, and we need to find and we need to fit a rectangle into it with the biggest area. Well, I mean, the opposite corner still must be red, so like actually not, because like over here I cannot use this tile, right? So I cannot use this rectangle like that. So it's not just the biggest rectangle to fit there. Okay.
Hello, Nerdzel.
Hello, Nerdzel. Okay. Just use Nagel's algorithm. What's Nagel's algorithm? That's the one for TCP. Hold on, let me think a little bit. That one? Does that have anything to do with this? I don't even know what the Nagel algorithm is doing. I already solved part 1? Yeah, part 1 was easy. TCP no delay, yeah. Well, I mean, isn't that kind of easy though? Like, so we basically let's fix one of the corners, right? Let's fix one of the corners. Then let's just find the one that is going to the right and to the bottom, right? So let's fix the top left corner of our thing, right? So when we fix that, the algorithm is quite simple. It is quite simple. I mean, you mean the TCP no delay one? Yeah, it's probably simple. I mean, this one is also simple, I think. We just go, we find the rectangle. Like, how far can we go on this line directly? First, we need to do that. I guess let's say that we did that somehow. And then we will try to extend, like, let's say for now that we extend one by one, one tile by one, right? So the area, like, so the width of the rectangle that we can feel is only going to be shrinking, right? So all we need to do when we extend the height of the rectangle by one tile is we need to find the leftmost like not green or red tile, starting from the left edge, right? And shrink our width to that. And then see if there is any red tiles over here and use the rightmost of those. to actually like and use that as the rectangle and update our answer. So this is still, iterating grid is quite slow. Yeah, I understand. I'm just like explaining the simple thing. So we need to do like the big jumps here, because we like obviously there is no updates that are happening in between the different y coordinates, I guess, of the red tiles. Well, not in between, right? The things can happen like strictly before, strictly after, and strictly on the red tiles, I guess, maybe, for simplicity, but not in between those. Yeah, we can just do like something simple like that. Just do the grid on GPU, easy peasy. Yep. It's more geometrical problem. Let's draw rectangles. Yeah, it is a geometrical problem, of course. So what do I need to be able to do quickly? I need to be able to quickly find, given the position, the next not green or red thing, right? But I need to not store that for every position, obviously. But I mean, we can just compress the coordinates. So if we just compress the coordinates, by the way, we can do it really easy. You know, we can do it like really easy. Just compress the coordinates. We're going to have 500 different x's and 500 different y's, right? And that's it. And then just do it in the stupid way, in the straightforward way. This could be a fun GPU problem, actually. Maybe. I feel like compressing the coordinates just makes it a lot easier, which means that we can iterate the grid now instead of doing something fancy. So if I just compress the coordinates, I would be able to just you know, I did consider compression, but for some reason I didn't think it would work. Why not? You only need to actually like uncompress the coordinates when you already have the pair of the things, right? Only then you need to get the original coordinates to update the actual area. To calculate the actual area. Yeah, let's just do compression. If part 1, then we do this. Yeah, it is going to run really slowly for me, though. I can see how this is going to be slow. This is going to be really slow in my interpreter. But we can just wait. It's fine for like a couple minutes while it's going to run. So let's just do axis is I'm just going to use the trip for it, I suppose. I mean, yeah. One of the things is that my lists, I don't have lists. Maybe I need to do more efficient lists first. Yeah, it's fine. It's fine. Let's just use the trips. Aesthetic collection trip. I'm just going to say trip create. Collections. You'd have to uncompress for each area calculation too, but that's cheap enough. Yeah, it's cheap enough, but not for me, because like looking up in my lists right now is not the constant time operation, but it's actually the logarithm. And it's like I have a big constant too, so it's like, you know. Yeah. So yeah, if I have the more efficient lists. Actually, wait, hold on. How do you do this in like general, in a functional language, so that it's actually like linear time, right? So that your lookups are in the compressed data structure, right? Because you don't use lists in the functional languages usually, right? I guess you just do this with like logarithmic lookups anyway. But it's because the interpreters are not as slow as my interpreter. It's still running pretty fast, right? So let's just say axes and y's is axes and y's is 2 trips. There's a big hint, but you don't want to say. Oh, you mean like I need to actually look at the input and like draw it? Maybe like the total area is small or something? Is that what you're telling me? Like, I remember on the last advent of code, some of the problems were actually like stupid, where you needed to inspect the inputs. Maybe. Did you draw it in Godot? I don't have the renderer. I mean, I can have the renderer though. Let's actually render this just into what? Into what do I render it? Into... Well, I mean, let's compress it first, and then wait. Liquid Cake did SVG, which was smart. Oh, SVG. SVG is a good idea. Yeah, I like that idea. So we just converted to an SVG just to look at it. Okay. I like that idea. Let's see, SVG. Polygon. How do you even do polygon there? We just do polygon, right? Polygon points is this. You literally just dump the input there, right? As is. Literally. Well, I mean, that's what they give you in the input. It's a polygon, not just a polyline. I'm not just... Yeah. You can do view box to scale the coordinates. Yeah. Yeah. How do I do that? Do I write a program that generates this thing? A view box, XML. You did Godot, but SVG makes more sense. Yeah, it does. Let's just do this in the beginning here. You know, we have the input as a string. I feel like we just put the string there as is, you know? Yeah, let's just do print here, you know, if if what? Argc is at least 4, and argv at 1 is equal to what? To SVG. Let's do this. Print. Let's remove the comment here. I just need a single polygon. I just need a polygon, right? Print. Joe Infinite Coder, thanks for the raid. Hi. View box is What was the view box? What is the view box necessary for
Hello,
SVGs?
9-inch nails, yeah.
Can it not like detect the view box automatically? Can I just not do this? Hello, Dev Ninja.
Hello, Nigel Ithro.
Polygon points is that, and then we will end the points. So we just print the input here as is, and then we just print. I need to close the quote, close the polygon, close the SVG. Like this. Something is wrong here. Incorrect escaped character. Oh wait, I cannot escape the quotes. I cannot escape the quotes yet, guys. Okay, I guess we can do that first. Yeah, let's do that first real quick. So I need to change my Lexer. And change my Lexer so that my escape character can be a quote. Then it's a quote. If it's a double quote, then it's a double quote. What else can you escape? This is the thing that I can escape right now. Is there anything else that I should add here? Is anything else useful? Not really, right? /B, what's /B? A bell? /R? Or let's say /R. R /R. B would be bell. I mean, whatever. Let's just add the bell, sure. 0 /0. /0 is like illegal /escape. Like the OCaml doesn't understand that. The hacks. I feel like the hacks I'll do later separately. Let's just do this simple thing for now. More escape characters. Let me just test this before. So if we have this, that's going to be a string like so. Okay. So print this is just steady IO print. It's just going to print this quote. Okay, that's what I want. Do all A to Z. Because you could split strings in some languages. You could also do /newlines. /newline. I feel like for multi-line strings, I want some other solution though. Not that. Hello, program lover. See program lover. Next Flake update cast. Christmas is coming and the song is named Jingle Bells and not Jingle Backspaces. Thought B was backspace. \B. A backspace character. ASCII backspace. It actually is. Okay, there we go. Now this is properly escaped, right? Sys cannot find sys in scope. Wait, what? Oh, because sys is not in the prelude. We need to do std sys. Okay, sure. Okay, let's do this. So we do run this SVG part 2 input txt, right? Something is wrong. More than or equal. Argc is a function. I should like the fact that it doesn't highlight here is something that I should fix. Okay, then we put this into day 9 SVG, right? Let's just do source day 9 input SVG. I'm actually going to commit this file then, right? Source day 9 input SVG. Nice. We don't see anything. We don't see anything. Do I need to like have the feeling here, right, or whatever? Is by default. It's not like I didn't do the viewport. Is that why? Can I open the source code? Also, I see that the coordinates, the x coordinate is no. There are small x coordinates. You probably need viewbox. You think? Let's see viewbox. So we need like 10 to the power of 5, right? For the coordinates. Like this. Oh. Really? I mean, yeah. That makes sense. I guess that means something. Wait, does it actually simplify? I mean, it does simplify the problem, I guess, right? It does. But wait, does it? I mean, yeah. This when you have a baby bottle in front of your PC. Baby bottle? This? I know. Since some time. Just make sure that it prints it correctly. It is not what you expected? Wait, what? Did you have a different thing? Is your thing not a circle, but like, do they give different shapes to different people? Wait, why am I scaling the thing, but it doesn't actually scale the thing? Wait, what? That's the VS Code viewer of the SVGs. I just scaled the background here. Try no new line where the points start. You mean like this empty thing in the middle is something that's not supposed to be here? I don't think the empty lines matter though. Here. That should not matter, right? The like any white space here is just ignored. Look at that, fill is white and stroke is black. Like this. The stroke should be like like it's not visible. So I guess this simplifies it. So the reason this simplifies it is because there's no like corners in this like middle line, right? That's why it simplifies it a lot. So I'm guessing that the biggest area starts at this corner specifically, right? Which is probably one of the first like things in the input, right? So we just do this. Maybe invert those then. Yeah, I guess invert. Yeah, because the background is black, right? Black, somewhat. Can you like have the color on the actual like control points in the SVGs? Wait, there is no like stroke. Maybe a stroke is not working. Stroke is black. Stroke. I did not do a typo here, right? Opening browser is just like VS Code is being bad. Copy path. Let's do red. Wait, the stroke is invisible. How do I make stroke visible? It needs a width, but like this example that they show me in the MDN also doesn't have any width, right? How do I give it width? Marker width. Wait, hold on. There we go. I want this. Hold on. There's marker. Path. Stroke fill is orange. Marker circle. You know what? Forget about this. We don't need that, right? Hello, Raymarch. We shouldn't work on SVGs. We should work on the solution here, right? Because I heard that some people took 5 hours to solve this. So yeah, hello, Raymarch. We're just doing the advent of code here in cast. Try stroke width 100. Okay. Like here, right? Stroke width 100. Stroke width. The quote. Oh, yeah, that actually worked. Okay. Right. Stroke width is 100. Wait, what? What did I just do? Oh, width, not width. Okay. Yeah, there we go. So the problem is that we need to find the rectangle with 2 opposite corners, meaning the control points of this shape. See, Shumara, hello. Did you solve this day? Did you solve this day or no? You're on day 4 still. Okay, maybe this is a little bit of a spoiler for you then. Bishimaru is doing the Advent of Code in SCD, right? Which is even more painful than the one that's doing Batcop. Batcop is doing it in Bash. Or maybe like it is more painful for me because my interpreter is slow. We'll see. We'll see. We'll have to wait for probably a couple minutes for this program to run. I saw day 4 part 1 in SAD today, so that's where I am. Okay, yeah, on day 4. Nice. Trip create. Okay, so I'm just trying to compress the coordinates here, x's and y's. Let's do that. We just do 4. We just do iterate the tiles. Yes, we'll have x and y, and I say that x's is. So this is just like different coordinates, right? Is what I want. Let's add to trip. I need to add the coordinate in 64. So I'm just going to add into x's x, and I'm going to add into y's y. Right? What do I do here though? It's not a semicolon. Alright, so since I'm using trips here, we just need to trip split the t at x, right? So data into if data value is less than x, then left subtree, else right subtree. Data. This is a pointer. We need to do that, right? What's the problem? Advent of code. All right. Let me just read this again for Raymarch. So we have the shape, which of a polygon with every like with every side being either vertical or horizontal, right? We have that, and then we need to find the rectangle with the two opposite corners. So we need to like basically find two corners, two control points of the given polygon, and construct a rectangle with those, and that should be fully inside the given polygon, basically, right? And we need to find the one with the bigger with the biggest area. That's the problem, right? So there is 500 control points, and the coordinates are like at maximum 10 to the power of 5, right? All right, so I'm starting here for now by just compressing the coordinates, because the coordinates are big, but we only have 500 different points. So we're going to use only the points that, only the coordinates that actually matter for us, right? Which is actually not only the coordinates of the control points, but also the neighboring coordinates. So I need to add to x's actually also x minus 1, and I need to also add x plus 1. And same for the y, because there can be like empty stuff there, right? So into y's, y minus 1, 1, like have this 1 1 1 1. Yes, I have that. So this actually gives me 1500 interesting coordinates, which actually is still kind of huge, right? This is going to run for very, very slowly, and like, so in day 8 it's not only like the speed, it also is going to, if I actually store this entire thing, it's going to use a lot of memory. I used like 8 gigabytes of RAM yesterday for day 8. Anyway, so over here, the ad is not finished yet. We need to split the trip here into 2 things. That's going to be like left and right. Yeah. And also I need to say that underscore and right is I need to split this again. Where's less than or equal than x this time? And then we say that I merge them back. So we just sudo trip p is trip merge left join singleton x. The obvious best solution is based on input inspection. Yeah, but do we want to do the best solution, or do we want to like do the generic solution? I'm wondering how slow this is going to be. Is it going to run before an hour? Can you elaborate? So if we actually, so we just was doing this, we were doing this SVG, right? This is what the input looks like, right? So it's not just any polygon, but it's this specific polygon, right? Which for which you can easily guess what's the biggest polygon, right? Or I mean, at least one of the corners is basically known based on this shape to be either this point or this point. So these 2 points is one of the corners. Because if you choose if you choose 2 points, one on the edge of the circle and one on the other edge of the circle, then because we're making a rectangle, it's going to go outside of the circle, obviously, right? So and that's not allowed. So one of the points is here, and then like it's basically turns it into a linear solution instead of it being a quadratic solution, right? Which is a lot faster. You wouldn't have expected those 2 points to be involved, to be honest. Well, I mean, the other, like, the 2... so, like, normally, if there was not this big cut, then the biggest area is obviously, like, one on the edge here and one on the edge here, right? Then you're going to have, like, this big rectangle, right? But it's obviously not possible in this problem because of this cut here, right? Which is why this point is one of the corners. I don't know, I feel it's like it's obvious here, right? But yeah, the problem requires the corners to be on one of the control points of those that you are given. Yeah. So you cannot just take a point over here in the middle. You cannot make a rectangle like this. I mean, it's basically like the same one anyway, kind of, right? If I do like this solution is basically the solution like specific to this is still basically a part of the generic solution anyway. We just already fixed one of the points to one of these, right? So yeah, maybe like less pre-calculation and stuff. Let's just see how long this works. So this is just me compressing the coordinates. That should not be too long, right? Because this is just 500 in each. But yeah, let's see. Print info boards are compressed, right? Axis is toString strip length of x's, y's is toString strip length y's. Let's do that. Remove the SVG, we don't need that anymore. Let's say over here, print chords red or something like that, because that also is not instant, takes a second to read the coordinates. So maybe let's do the iter I here. Wait, I don't have the iter I. Yeah, I don't have iter I. Sure. At I is 0. I plus equal 1. And compressing chords to string I. To string list length else. All right. Yeah. Even although this is really fast, right? It's just 500 times logarithm of 500 or whatever. So this is in a normal language would be just a couple milliseconds, I guess. Well, not a couple milliseconds, but like, I don't know, like 10 milliseconds, 50 maybe. Okay, so we have two. Wait, why is there 2000 coordinates? If I have 500 different ones, shouldn't I just have at most 1500? This seems incorrect, right? How can I have more? Because I only add, like, for each x, I add 3 different ones. And we have 496. So 496 times 3 is the biggest number that we should have. But we have actually 2200. Am I stupid? Or is there a bug here? Let's see. I'm just splitting left, and or equal. I ignore the ones, so basically I ignore the ones that are equal to x. I insert x. This is basically like just a set using trips. Can I do like trip print trip to string? Because I had that, right? Trip to string, axis, x to string x, and part 2 of today broke my cell. Okay, so this is, yeah, this is wrong. So I have the same thing multiple times, and this is also not sorted, which is incorrect. Right? Why are the smaller numbers in the beginning and bigger numbers are at the end? Hold on. If data value, so like we basically put everything that's less than x into the left subtree and everything that's more than or equal than x into the right subtree. So here's my left and right after that. So left is everything that is less than x, right is everything that is more than or equal than x. And then oh wait, that's right, because then to split here, not the original t, I need to split the right that I was that like the result here. So everything that's more than or equal than x should be split further in case I have the element that equal to x. I found the bug. Human uses trips like hardware engineers use AND gates. Yeah. This is still not correct. I have 1594, 1594 here. Any other bugs here? Or is my trips bug, or are my trips bugged? How about we go on the example? Let's go just on the example. Right? So we have 24 axis, which is completely wrong, right? Also, this seems like this is completely incorrect. Wait, why? It's like decreasing instead of increasing. The opposite of what I want. What? If it's less than x, then we'll put it in the left subtree. More than or equal is in the right subtree. Then less than or equal is in the left subtree. Just call reverse on it. Yeah, but also, why are they duplicated? They're supposed to not be duplicated. That's the reason, like over here, I'm removing everything that's equal to x. Put it into the left subtree, and the left subtree, I'm just discarding it, right? So, what? Hold on. There's no way I have a bug in my less than, right? Hold on. How about I do this? dbg print 0 is less than 1. Just to make sure, you know. Okay, it's true, right? And like 1 is less than 0 is false, right? Just to like make sure. Yeah, it's false. Okay, nice, good. Line 86 might be the bug. 86, this one. Trip is join. So like when you join the trips, on the left is the like the ones that are less than x, and then on the right we're joining the x itself and right. So right is the things that are more than x. You know what? Let's rename this. Let's say less than x. This over here is more or equal, or like greater or equal. Let's just say less, greater or equal, and this right is basically greater, right? So we say that it's the numbers that are less than x itself, and then the numbers that are greater than x, right? So like it's supposed to work. Trim singleton x. Yeah, what's the problem with singleton? Like we insert the x into the set, right? So there are numbers that are less than x before that, and then greater after that. Let's do dbg print here. I don't know. Do I actually like it was working for the previous days, right? So why is there a problem? Wait, value is less than x. It's like the opposite. If x is less than value, so it's in the so x is in the left subtree. I understand. Yeah, my bad. What's that? That's the dereferencing operator. I don't know. Do you not like it? In Rust, it would be starty, I guess. You only asked? Yeah, but do you not like it? One of the things that we do is like, yeah, we do this, right? So like B is a point, is a reference. So we get the field Y by dereferencing and then getting the field Y, right? So postfix deref is based, yes. So Odin uses this the same one, right? And like Zig uses dot star. So like the fact that it's postfix is good for sure, but like it feels a little weird to type it still. I don't know. Not the weirdest thing though. Currently, the syntax that I dislike the most right now is the colon here for my variants. Any suggestions for that? This is still like the best that I could come up with for my variants. But yeah. The other alternatives don't really work. You have to press space twice to get a single space after it. It's awkward to type on your keyboard. You have to press space twice to get a single space after it. Trib.write subtree. It doesn't work like that. No. Well, I mean, if you have it as a value, then yes, sure. But the problem is in pattern matching. Well, I mean, hold on. Wait, hold on. If we do trib.write subtree, maybe that actually will work. The problem is the pattern matching, I guess. Because when you match a variant with the things, right? So you cannot just say like some or none, right? That's the thing. So if you say option.sum, that removes the ambiguity because the fields cannot be used. Like using a dot as like a field does make sense, right? So we can use that for the variant, yeah. But if I don't want to specify this, we can do like underscore dot. But is that actually better than the colon in this case? You could also do colon like Rust. Yeah, but colon is like I use colons right now for type ascriptions instead of colons like Rust. All right. I mean, I can switch those. I suppose I can make this a colon and that one a double colon. But I don't know. You think yes? Yes. What? Do dollar like bash? Dollar sum? All right, we'll get back to that later. Underscore.foo is okay. Is it better than colon? It's 2 characters instead of 1 character. But underscore.foo makes sense. Yeah, I guess it does. Although not right now, because right now, like it's not how you construct these things anyway. If underscore is generally stuff that is inferred. Yeah, underscore literally means please infer this thing. So yeah, that does make sense. I'll think about it later. Let's get to this. Colors are compressed. So like this is now like. So but why are this? Is there still duplication though? Now that makes no sense. Why am I debugging this simple thing? Less, greater. and x itself. Rust has a use as stupid type, as colon. Yeah, the other way around, stupid type as s. Okay. Although, like, it's kind of like a special syntax a little bit in that case, I suppose. I'll think about it later. Let's find the bug first. Coordinates are compressed, 24. 1122. Swift has .foo. Yes, .foo would be really nice, but I don't. But I cannot do that because of the fields, right? Because that's how we do fields. So there should be a distinction. What about this is a variant foo? Anyone sees a bug here? Less, greater, or equal? Join less, x, and greater. Let's print before split and after split. Right, like this. So we have had empty. We got 6. We got 6. We get 6, 7. Over here we're adding, I guess, another 0. GBG print x. Let's try that. So I'm adding 10 here, we got 10. Adding 11, adding 12 over here. So over here we're adding 0 to 0, 1, 2, and we get 0, 0, 1, 2. 6, 7, cannot make it up. I mean, that's the example, right? Wait, no, it's not. Wait, how do we get 6, 7? Oh, because x minus 1 here is 6 and x is 7. That makes sense. Why is this not working? Let's print left, and let's print less and print greater. How about that? Print like that, something. So less, okay, less is 0, but greater is 1 and 2. Now that makes no sense, right? Because the less is obviously should be empty. If x is less, then we do the left subtree. What's reference ident? It's just reference, just like in Rust, right? Rust or C? I mean, in this case, it's the same, right? Because I'm mutate. Okay, yeah, I don't have the mutability yet. I guess this will be later Like in this case, this is going to be mutable. I just don't have that implemented yet. Right now, all the references are, I guess right now it's more like C. Or I guess right now it's more like Go, because we have like garbage collection, right? And stuff. So this should be less than or equal still. I forget. So like this is, should I split the left subtree? Should I split the right subtree? That's what this function should tell me, right? So if I have the single thing, less than or equal, I'm splitting the left subtree. But what is this node itself going to get into? That's the question, right? This is weird. Hold on. I'm confused right now. What am I trying to do here? I mean, this fixed it, but I'm confused with my own trip usage. A trip split gives me like the node splitter. Takes the node splitter function, which decides whether I should split the left subtree or should I split the right subtree. Or we can also split the node itself, but we don't do that here. So in this case, if x is less than or equal than the value that is inside the node, so if the x is equal to the value that's in the node, then I should split the left subtree, yes. Well, I mean, yeah. And x itself this one itself belongs to the right subtree then. Because this one is greater or equal than x. So maybe like, need to write it like this. So, but this is what I split. This is not where this thing belongs. Maybe I should just, maybe I should change this so that like the node splitter should tell me where does this node that I'm currently in belongs. Does it belong in the left subtree or does it belong in the right subtree? And this over here is what I'm splitting instead. So it's like a little confusing because of that. Probably just a naming issue here, right? So if the value is more than or equal than x, then it's then we split the left subtree, but this thing belongs to the right subtree. And in this case, we want this to belong to the right subtree if it's more than or equal than x plus 1. Right? Yeah. Left and right, you mean top and bottom? Okay. Okay, this is done. Right? We have compressed the coordinates after okay, now we can actually go to the next part. 1.5 hours for that. Okay. Today is going to be a long day indeed. So now we should only have like 1,000 different coordinates, right? Less than 100. Yeah, 750. Nice. So what do I do next? What do I do next? I change the coordinates. I change my polygon to use the indexes in this, right? So I also need to find the index of the coordinate and to change my polygon into the polygon that works on the split coordinates, right? So Yeah, so like let's call this the vertices, right? Vertices. I don't have the list map, so we are going to create a new list, and then we iterate over the original list, which was called tiles. So we have X and Y, and we just do what? So I need to like find X, right? In this thing. So index of if I give it the trip itself, and X, right? This is in 64, whatever. So the index of this should return the index. We'll use in 32s then, I guess. Here. So how do I do that? I need to just say that trip split t into, once again, and to, so the index of is basically the amount of things that are less than, right? So less, and this is just the same stuff. And then I just return the length of the elements that are less than x, right? This over here could be extracted into a function, but whatever. Function main accepts a reference to a reference of a character and an integer. The aforementioned main accepting a reference to a reference of a character ref, making it argv and an integer. What? Are you coming up with the language that is readable because it's English? Okay, so we just say that x is index of in the x's I want to find the x, right? And y is index of y's y, right? Like this. I also kind of like want to maybe assert here. Whatever. We don't need to assert anything, right? Do we? Nah, we don't. That the x actually exists in the set, I guess, right? Over here. Yeah, whatever. Yeah, so we just say list push back into this x and y. There we go. So this is the list of x and y's, which is now an integer, right? So we compress the coordinates. This is going to be calculated compressed polygon, right? Right. How long does this work? Is it also slow? Should I also give it the progress there? I probably should. I probably should always do that. Actually, no, that was really quick. Like, finding this was quick. All right. Nice. So I calculated the compressed polygon. Maybe I can print it. dbg. Let's see, trip to string. es inner. Okay, let's just do that. On the example. That doesn't work. No implementation of type as generic. Oh, I cannot make it toString here. X and Y. And toString X plus comma plus toString Y. Do that. Okay. Let's do spaces here instead because we do comma to separate. So 4, 1, 8, 1. So the original polygon is this 7, 1, but instead of 7 we now have 4, right? So the numbers are all less than the original numbers. Okay, nice. Finally, now we have compressed the thing and we can solve the actual problem, right? For the whatever, for the whatever. Well, how do we do that now? Oh my god. We want to fix some point. I'm just actually thinking because of this SVG, if we fix this point, we can just no, we cannot, right? Yeah, no, never mind. Even if you iterate like the most stupid solution is um uh, is like cubic, maybe. So we like we fix this one. This one is only 1, and then the other, and then we wait. No, never mind. Yeah, we just select the other point. And then we see if that contains the thing. So it's, yeah, the stupid one would be quadratic, but we can do linear. All right, so we fix 1 point, right? Then we go up as far as we can. We figure out how far can we go, basically, right? How is quadratic sufficient? Well, I mean, the quadratic over the amount of vertices, which is 500 squared. I mean, even 500 cubic will be still fast in a language that is fast, right? Or what's the question? Or do you tell me, or do you tell it to start those 2 points? Well, I mean, yeah, the one of the first points is this. I mean, this stupid solution is cubic, I guess. And if, I mean, even that is not like that stupid, I guess. Anyway, so we like, okay, so we fix the point and then we extend left and up, right? So first, what we actually do is, let's actually like, let's maintain how far left can we go, right? So by, so we start like over here by a single line, like that. Then we try to go higher up, and we just say that if the pixel that is higher up is empty, is outside of the polygon, then we like say that we cannot go that far, basically. That's all. Yeah, what's the problem? This is the advent of code, day 9. The problem is that you are given the polygon and you need to find the rectangle with the corners, with the 2 opposite corners being one of the corners of the given polygon, and the rectangle must be fully inside the given polygon, and out of all of the variants you need to find the rectangle with the biggest area, right? And this is what our input looks like. Yeah. let's see. So we start at a certain point, right? At which point do we start? At which point do we start? So I only will try to do to left and yeah. To left. But both up and down, I suppose. Should be possible. Yeah. Yeah. Okay. Let's see here. What do I need to do? Let's just iterate over all of the things for now, for the example. So we just say that for... we just iterate over all of my vertices. We iterate over all of my vertices. So we have x and y. Just say v here. So that's my point. So first what we want to see is how far left can we go. Do I actually build the full map? I cannot do the full map. Or can I? Actually, I know how I can make it faster, because my strings are faster. My strings are fast to do the indexing, so I can literally build the map as like a list of strings, you know? Actually, you know, to make it really fast, yeah, to like mimic the arrays, because I don't have them, I can just store the entire map in a single string. That makes sense, right? Let's do that. Let's do that. Let's actually do that. Then we actually have the two semicircles. The biggest area will be the tree. We need to have the not the triangle but the rectangle. It's centered top or bottom, and the leftmost and rightmost posts are barely closer to the center. No, because our corners must be one of the corners of the original polygon. We cannot do the rectangle like this. Because there is no points over here on this line. Right? So the only corner that we can use is this one. Or this one for the biggest area. So it's something like this is going to be our answer for the biggest area. ToString x plus toString y. Okay, this is just me printing the thing. If verbose, let's do that. If verbose, then we print. Say over here somewhere in the beginning. Verbose is false. Yes. Verbose. Nah. Just debugging some stuff here. Rectangle, yeah, the rectangle. With two of the opposite corners being in the original corners. Not all four corners. So we need to pick two of the points of the original polygon. Make it a rectangle with those 2 points. Right? And that rectangle must be fully inside the polygon. Calculated compressed polygon. Nice. So now, after I do that, what did I want to do? Lost. There was time where I was actually really quick at solving these things. I'm old now. I just forget what I wanted to do. Oh, I wanted to construct the map. Yeah. So like map is just going to be a string. Right? Map is going to be a string. And then we just we are going to I don't like that. I don't like that. I don't like the map. I don't like the map. Let's do it without the map. I just want to know how far left can I go. Let's do that only if this is the previous point, maybe. Right? Where are these lines in my input? Should I like, so the only corners that I should consider are the ones that are after long horizontal lines, right? But not for the example. Not for the example. Is there like yeah, this is what the example looks like. So this over here is the answer. So I will select this point. See that this is my how far left can I go, which is still just on this same segment. Yeah. I guess that will work for me too. Yeah. Okay. That makes sense. I mean, so basically I start, I iterate over the edges of the polygon, and I use this horizontal edge as my starting point, right? And then I'm going to like move up, and then when I move up here, we will basically like shrink our horizontal. How far can we go to this point, right? And then we continue going up and going up, and that's it, right? What we want though is what I want. I don't know. Let's do 4i in 0 to length of vertices. Basically, you want a cube voxel meshing algorithm, maybe, I don't know. It's not 3D though. It's 2D, right? So it's not a cubes, it's squares. Voxel meshing. Is that what they actually do? They find the yeah, I guess like they do it in games like Minecraft, I guess, to reduce the amount of vertices in the resulting mesh, right? Yeah. Makes sense. Yeah, but they do it for each 2D plane. Yeah. Makes sense. So we like find the biggest one, add it to like the list of faces, and then like continue on the polygons that are still not meshed. Okay, previous is I plus 1. Do I have the mod operator even? Do I have mod? List length vs. Do I not have that? Skip an unexpected this. Do I have mod? No, I don't have mod. I don't have this. Let's just say that previous, or I guess next, or whatever. It doesn't really matter here. Right? Plus 1. I just say that if this is equal to list length, then previous is 0, right? Or fine, we'll call it next. So we have the edge now, from I to next, right? So A is list at I, and B is list at next, or whatever, right? I want to say that if A is equal, if A Y is not equal to BY, then I want to continue, because I don't want to I only want to care about horizontal ones. Right, only horizontal ones, and we always start at the right point, because that's enough to solve both example and the actual input that we are given. So we say that if AX is more than BX, then, so I cannot do AB is BA yet, but I can do I just do that real quickly? Maybe I just do this real quickly. That's a to do. We do it using the third variable b. A is B is A is T. Fine. So we have A is to the left of B, right? Okay. So now we want to start going up from the point A, right? So I need to like really easily know if yeah, like what I would want is to know if the point is inside. So I actually need the map then, right? I actually need the map then. Shit. Okay. Let's say map is the thing. Let's create the map. You know, representation is string. We are going to represent the map with a string because that's faster, right? So yeah, I guess I actually need to fill the things. Sure. Let me take a look at my input again. Let's do, first of all, how do we get, right? I need the size here too, right? So width and height is something that we need to have here. Let's call these just N and M, maybe. We have bit manipulation. I barely have anything. No. I don't even have arrays, which is why I'm going to use strings here to mimic arrays. And I will like flatten the entire map. I will put it into a flat string so that it's faster for now. Well, I mean, bit manipulation. You want me to put this into like a bit map? I feel like that's nah. Do you ever program get into your projects after a shit sleep? Like I slept 4 hours and I feel like my brain's so offline. I feel like it's wiser to not touch anything, even if I kind of think I know what I'm doing. I don't know. I feel like I always sleep well. I sleep a lot usually. But usually, like, my brain is offline when I don't sleep for a long time, because that happens. Yes. But I don't think it ever led to like any real breakage. It just means that the progress is really slow. All right, let's create. Create is you know, n and m into. It's going to return the map. So I'm just going to say. Wait, what do I even have in my string thing right now? Hold on a second. Just going to do that. What do I have in my strings in std? Do I have there string.length? I don't have a way to construct a string, right? Of a given length with a single character. No, I cannot. Can I construct I have substrings. I have at. I don't have set at. I don't have set at. So wait, I can actually not do that then. Unless I improve my language. Because I cannot mutate my strings anyway. Or construct a new string where a single character is changed. Yeah, I cannot do this. Even. You sort your files by day? What do you mean, like here? I mean, we just save all of the files for every day so we can see all of the solutions. Like, it's just so that we still have all the code for the previous days. I mean, I do this 0, 1 so that when we go to 10, it's going to keep sorted. So yeah, that I guess that's why I call them 0, 1 instead of just day 1. This is going to be really slow if I do it using the trip here. But we can change that later. Let's make it slow first, right? So fine. This is going to be a trip of use std collections trip, right? So it's going to be a trip of trips of and in every one I'll just put the integer, a number in every one. That makes sense probably. Yeah, so wrapper is not a string, which we will instead say wrapper is trip create, and then we do for I in 0 to n. Wrapper well, I mean, I can create at least it really fast because my trips are immutable structures, so I can create the one row easily. By saying that row is trip join row and singleton. Actually, like, because I'm just creating the ones that are like empty like this, right? What I could do is to make this faster by using an existing trip for every like power of 2. Whatever, forget about it. Okay, so we do for I is this we just say that wrapper is strip join wrapper row, right? So I just duplicate the row n times, and that's my representation of my map. In 32. Was it saying this is not in 32? So row. Yeah, why is row still the nested one? That makes no sense. Oh, wait. It's because over here we also need to do trip singleton row. There we go. There you go. So now we have that. Okay, sure. Sure. So for map, I want to say what? What do I want to say for map? How do we draw the map? Right? Because I want it to be drawn like oh my god. Um let's say at. Let's say at. Let's say at is map ij, going to give it a reference to an int. If I give it a reference so that I can mutate it, then this does not work because I will duplicate multiple rows at the same time. I don't want that, right? Which means that I will have to create the row every time. Fine, let's do that. So that's already like really slow right now. So at is just going to be trip at map prepper I at this j, right? That's what I want. So this gives me the reference to the thing. Maybe I want to like have a get map ij, just going to say at map ij dereferenced, because otherwise dereferencing is a little bit annoying. And this we will use for mutating. Let's actually just call this at mut then, and this is going to be like at. Okay. So map is map create. N is going to be length of axis, and M is going to be length of y's, right? Yeah, so for every coordinate we need to have the thing. Okay. Print creating empty map, just so that we understand how long it takes. Created empty map, you know. Let's do print info progress to string I to string n. Okay. So how do we do this? I guess the way we do it is we need to go over all of the edges of the thing. Is it given in clockwise or counterclockwise order, by the way? And 7 1. This is 7 1, 11 1, 11 7, 9 7, 9 5, 2 5, 2 3. It seems like it's counterclockwise order, right? It's counterclockwise order. So because of that, over here I will just be drawing the map here. We only care about horizontal lines still, right? But for so I swap them, and the thing is, so what I'm going to do here is I'm going for every horizontal line, if it is going if it's going in positive x, so it's going to the right, then I'm going to add 1 into each cell of the edge, and if it's going left, then I'm going to subtract 1 from each cell on the edge. Actually, I want to subtract from the thing above it, right? Hold on. So like we go here, I add 1s to each of these cells, right? I go over here to the left, I subtract 1. I mean, sure, let's just subtract 1 over here, whatever. No, let's subtract 1 from over here, right? So the reason to do that is that then we are going to iterate over the map again, over every column, and we're going to calculate the prefix sums and put the prefix sum into the cell. And basically that is going to lead us to have a 0 for every cell that is outside of the polygon and 1 for every cell that is inside the polygon, right? That's how we draw the map. With the complexity being proportional to the size of the map. But not exactly, because I'm using trips to implement the map right now, but that's implementation details, right? So yeah, I'm going to say that y is equal to ay, but in this case, if it's going to the right, I'm just going to say that y plus equal 1 here, right? Yeah. So now we go for x in ax to bx plus 1, so including both of those, we say that map at x and y is going to be what, plus equal at, right? Like that. That's what I want. This needs to be in parentheses. I see, actually, like this gives me the thoughts that in my language, so like right now we just use spaces for applying functions, right? So we don't have actually the syntax for calling functions that requires parentheses, right? So we have something like this, you know, like object dot like function f, and over here we have arguments, right? So what I want to do is I don't know, I want to get the result of this and get a field, you know, the field which is the result of me applying a function or a method or whatever, right? So in Rust or in like most of these languages, right, you would just say object.args.field, right? But we cannot do that because this over here is treated as a space, as me calling this function with this argument, right? So we can do like the function application. We can keep the space here for function application, but the function application should be higher priority than the actual field then. No, it should not be. It should be the same priority as the fields, right? So the so if we see the object.f_args.field, this would be parsed as object.f, and then we call that with args, and then we do .field, right? But that would be really weird, because what if I actually want to have the function that is stored inside of the object and call it with this? This is really weird, right? I think because of that, I might actually go back to the syntax of function application, which requires parentheses, right? Because in this case, if I actually want to call the f, which is the field of object, with this being the argument, I would have to put these things into parentheses, right? Explicitly. Wait, what? Wait, what? I mean, yeah. But then the function application is actually the same priority and as the dot. And the function application can be the same priority as the dot. Right? That makes sense? Maybe? Right. We'll come back to the syntax later. But yeah, like it will allow me to just say map at mood and then just dereference that, right? Without these extra parentheses, which are kind of annoying here. We just do this plus equal add. All right, need to do more progress here, right? Print progress. So this is going to be at least length vs. So this is going to be drawing edges. So I've been drawing edges. Done drawing edges. Then after that we need to after that I need to fill the map. Filling the map. Done filling the map. Okay. So now I just go basically for I in 0 to map n, right? For j in 0 to map m. We say map at ij. We just need to say plus equal map at I j minus 1. That's all that I need to do, right? But this means that I need to start j from 1, not from 0. That's all. And this needs to be like this, dereferenced. And I guess this also needs to be referenced, which means that we can do get here. Reference is not integer. Field get is not there. Wait, yeah, this should be at mood, and this should be at. That's what I called them, right? There you go. Okay. Done filling the map. Okay, how about I actually print the map though now? Let's print the map. So I need to do I want to print the progress here though still. Too, because that's also potentially slow. I out of map n. Right? Okay, so now I print the map, so wait, how do I print the map? Like, the print always prints to a new line. I don't have the way to print without the new line. Let's see, let's do map, let's do trip iterate map wrapper. So this is going to give me the row. Right? So I want to say that string here is going to be this. Trip iterate. I'm going to print as in the end, iterate row x into if x is equal to 0, then space else hashtag. Let's do that. That's going to be the character basically, and then we just say that s plus equals c. Okay, that should work. Let's see. Done filling the map. It feels like, okay, hold on, what? This is not correct. This is not correct. Why not? It looks almost. Like, what is this? This is wrong. It can be rotated though, that's fine. Let's just do over here s plus equal to string x. Right? Yeah, this is actually -1 here, which is wrong. I have 1, 1, 1. Okay. How about I don't do the filling of the map then? And see after I drew the edges. So I have drawn the edges. They are like horizontal like this. Yeah, I see. -1, -1, -1. Yeah, that makes sense. I need to do something about the left and right edges here. So because this, so like if we look at this vertical column here, right? I start feeling here, then I basically stop feeling here, because this over here is the thing that's going to the. Wait, what? No. No. Yeah, it's like because I do both of these. Yeah. Hold on. How do I do this again? Why am I so bad? I need to. When iterating over the edge, I need to not do inclusive right range here, but that's going to do what? That's not going to do anything bad, right? That's just... No, we start here, we end here. I don't want to add one in this one, but I do want to add one in this corner. What's the difference? The difference is the rotation is clockwise here and counterclockwise here. So I need to see the next. Or something. But then, like, what about the other direction too? This is annoying a little bit. Because we have like both edges inclusive. One and then the second end. Two, three, boom, 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 boom. Basing this thing on the rotation is not what I want to do. But I have to, right? There's probably like a cleaner way to write that code though. Okay, fine. Let's do two separate things. Let's do two separate things. If ax is less than bx, which means that we have the one that's going from left to right, right? The one that's going from left to right. In this case, I want to go for x in ax to bx, and I want to add one here, right? Plus equal 1, where y is like our original ay. But I only want let's do C, right? C is the next one. This over here should not always be bx, right? So end is if cy is less than by, then it should be bx minus 1. Otherwise it's just going to be bx. We go from ax to the end here. That makes sense even. So otherwise we need to do something similar, right? We say that y that we're going to be mutating is ay plus 1. Over here this is going to be minus equal 1. And so we start at bx, right? Because that's one is the lesser one. And we say that end is either ax minus 1 or ax. If I go to the left, then in this case, wait, is the start also sometimes weird because of that? It needs to be moved. Like over here, I don't want to subtract 1 here and subtract 1 here, right? I want to only subtract 1 at the very end, right? Oh, wait, maybe I just do for the vertical ones. Wait, hold on. Hold on. I know how to write it cleaner. We do Control Z here. That was okay. Right? This was okay. This was okay, but like we just need to fix the things for all of the vertical lines, right? So if the vertical line is going down, let's see, if it's equal, then we do this thing, right? Otherwise we do some other thing. What do we do? This horizontal and this one is vertical. If ay is less than by, so I was going up. Yeah, we just do bx excluding, right? We just do bx excluding, which means that I will have drawn this. I will have drawn this, but when I'm going up, I need in the bottom to also add 1. So if ax is less than, if ay is less than by, then I need to add 1 at ax ay plus equal 1, right? And if we're going down, now, like in this case, right? We're going down. So I did this minus 1 and I did this minus 1. So nothing actually happened. Wait, yeah, but this over here is broken. And this is still me going up. So does it mean that when I am going up, I should fix both the bottom and the top? Add 1 here, subtract 1 there. Maybe that's what I need actually. So, and at by plus 1, we subtract 1, right? Like this. Oh my god, I'm so bad. I'm so bad. Let's see. Looks better now. Then we fill the map and we do this, right? Ah, there you go. We have the actual map drawn on the screen. Okay. That took way too long. Way longer than needed. Do I just have the transposed one? Because I have X as the column, right? Maybe I need to, yeah, because I'm iterating. The row is actually the horizontal. That's like the column actually. Just draw it better, right? So for X in 0 to map N, we say that this, that, this, and over here don't iterate, you say for Y in 0 to map M, right? I just say that X is map at map XY, right? Like so. Oop. Do they have in this graph the wait, what? X. Oh yeah, we need to go for Y in 0 to map M and X in 0 to map N. Right? There we go. There you go. Now we actually have like the same orientation as the example. Finally, 2 hours for this shit. Okay. I'm good at programming. Okay, now that after that we have done that, should I try printing, should I try seeing how long does this work for the actual input? Compressing the coordinates takes 1 minute. And then I'm creating the empty map takes this long. Okay. I will not even like be able to wait until this is done. Nah, there's no way. This is very long. No, I mean I will be able to wait for this, but let's see if it draws the map maybe after that quickly. Creating the empty map. Because drawing the map, I mean, this is still like, yeah, no, that's not, there's no way this is going to be quick. So 10 minutes to create an empty map. Because I'm creating the trips here everywhere. Yeah. The solution is just to add the lists. Wait a second, and I used more than 1 GB of RAM too, right? So yeah. So 200 lines is 1 GB of RAM. So I will need like 5 GB to store this map, which is probably fine though, right? Using too much RAM. Well, just like yesterday, it makes sense. Do I add the erase here, or do I mean, you're on par with web devs now? Yeah. I did not switch still since yesterday. Okay, fine. Alright, anyway, let's say that this works, right? What is my next goal? My next goal? My next goal. I forgot about the thing already. We need to fix one of the corners, right? and then go left as far as possible, and then maintain how far left can we go. Okay, so yes, we'll do this. We still need to iterate over all of the edges, I guess. Let's iterate over all of the edges. There's only going to be a couple things that we're actually going to check. What we want to check is what? Next is this A and B. Let's copy that code here. Next is I+1. Next is not needed here anymore. You're going to sleep. Good night, good night, good night. Good night. Leaderboards. Yeah, there's a lot of people with the gray star here. It's half done. What's my RAM? Is my ref half done? Half done? No, I still have a lot of RAM. Yeah, I think we're safe. How do I want to do this? I want to only check if AY is not equal to BY, then I'm going to continue. So I don't care. I only care about the horizontal ones, right? And I will want to like swap them again here, I think. Right. I'll want to swap them again here. So I'm only checking the B here. The B is my thing, right? Okay, so how far left can we go? How far left can we go? Let's say that my position is B, right? That's my one of the corners. One of the corners. One of the corners is P, which is B, right? And then like how far left can we go? The left coordinate is going to be AX, basically, right? And then we do something like this. We say we do like while true, just like do a loop, right? We want to so we want to like check the current position. Well, actually, like it's just going to be A, really. It's literally just A. A is my position. Right, so what I want to do is like A, so what we want is like check rectangle A AP, right? So one corner is A, another corner is P. Or maybe like A and B is my two corners, so I should keep it B. Okay, so we just two corners, A and B, right? There you go. But I want to move the A. I want to say AY plus equal 1, right? And I want to say basically like while map at AX and AY, why this is empty, right? I want to say that AX plus equal 1 too, right? So I move that edge to the right. If it so happened that AX is now actually more than BX, then I'm going to break completely, right? I'm going to break completely. How do I break completely? I want to like continue this loop, right? Yeah. So no, I want to no, at this point I actually break this loop completely. Yeah, I want to continue this loop. Have unwindable block here. So I'm just going to unwind the block. Right? Yeah. Okay. Yeah, I just need to check rect AB, which means that I need to check that A is the valid like original corner, which we could like store the original corners all in the thing. Or I can also, another thing that I could do is I can make the corners they do hashtags, right? X and hashtag, you know, let's say that if X is equal to 0, then this, else if X is equal to 1, then X, else hashtag. That's what I want. Did you solve part 2? You just gave it another 30 minutes and it's driving me insane with all the damn edge cases I encounter. No, I'm not. Wait, why is there progress from scratch? Oh, done drawing edges and I'm now filling the map. Okay. my solution is going to be really, really slow because my interpreter is really slow. But I'm almost done actually writing the solution though. Almost done writing the solution. But I'm also like, I don't know. I feel like like back in the days, like 10 years ago when I was actually like doing this like as a sport, I would have solved this problem in like I don't know, maybe like 30 minutes at most. I'm getting old. I forgot how to do programming. Answer is 0. dbg.print answer. Okay. This is so slow. I should like wait for. I mean, yeah, it's slower than 1 a second here, right? What is this progress right now? I'm done. I'm doing feeling the. Wait, what am I doing? Done drawn edges. I'm feeling the map. Yes, I'm feeling the map. So this is just like the linear thing, and the linear thing is really slow, right? Because this. Okay. RAM is under control. Like I literally just want to mark the spots which are the proper corners, right? Yeah, so I'm just going to say that I'm going to say list iterate these X and Y. I'm going to say that map at mut map X Y. The referenced is equal to like I don't know, 100, whatever, it doesn't matter, right? Doesn't matter. Okay, let's stop this. Let's go back to the example, right? So yeah, we are marking, as you can see here, axis is all of the insides, but hashtags is the actual corners that we care about, right? So I can actually check it also quickly here. So I say that if map if map at ax and ay is equal to 100. 100 should be like actual corner, right? Then we need to update the answer. Actual corner. Actual corner is 100, whatever. So in this case, I need to like uncompress my coordinates, right? So A is uncompress A, and B is uncompress B, and then I say that area is absolute of bx minus ax plus 1 times absolute by minus ay plus 1, right? Like this. And then if area is more than answer, then answer is area. That's all. So what is uncompress, right? What's uncompress? I think I will just put that function somewhere here, right? Uncompress is going to be, if I give it the point, x and y, this is going to be x is uncompress uncompressed coordinate x, and y is uncompressed coordinate y, like that, right? And uncompressed coordinate is just tx is just going to be trip at tx dereferenced, right? Is that what I want? Probably. The answer is 21. Is that even correct? Because it's 1, 2, 3, 4, 5, 6, 7. Wait, what? 24. Is it 24? Let's say area over here, right? Let's dbg print AB area, like this, right? So here's what we check. Area is 18. So A is 2,5, B is 7,3, area is 18. Do we have 2,5? We do have 2,5. Okay. 7,1. 7,1 is this one, right? So this is 7,1 and this is like 11. Wait, what? 7,1 is this one, right? Because they start the y coordinates go from top to bottom, right? So this is 7,1. Yeah. 7,1, 11,1, 11,7. Yeah. Okay. So what should we check? Like 2,5. 2,5 is this one, right? 2,5 and 7,3 and 7,3 is this one, right? So we tried that. Oh wait, I understand though, right? It's because yeah, okay. It makes sense. It's because I only go in one direction, but we also want to try the other direction, right? So I try to go left and up from the current corner, but we also should try going left and down. So we need to actually do the double work here, you know? We need to do the double work here. And over here, instead of plus equal 1, this should be like add, right? And then I should say that, let's say this is like tri-direction. Tri-direction is direction into all of that, you know? Tri-direction. Can I just say A, B direction? Right? A, B direction. So that I don't mutate my original variables. I will try direction AB1, and I will try direction AB and -1, which is 0, negative 0, -1, right? So this is not add. This is direction. Is what I want here. Okay, and now the answer is still 21. 2573. 2573. Wait, but how is that possible? AY plus equal direction. Did I go in the other direction now? If I only try the other direction. Wait, if I only try the other direction, then it's 24. It's because I actually, wait, am I actually like mutating something? What am I mutating here? I'm mutating AY. But A is this A, which is a different one, right? Oh, I see actually. This, okay. Now this is because my tuples are actually always by reference. Even if I don't pass them by reference, I don't do the deep copies right now or whatever. So it's actually not working. I need to actually do that. A is X is AX and Y is AY, you know? I actually need to do that to copy them properly. You actually got the solution? Nice. Okay, the answer is 24, even although I tried both directions. Okay, nice. So I can remove this debug print. I want to... I want to... So before I actually try to solve this for the actual input, before we wait for eternity for the thing to run, the thing to run, I need to not try every horizontal thing, but only the horizontal things that are really, really long, right? So that we wait for the smaller eternity, right? Which is if my horizontal line is really, really long, right? So what does it mean to be really, really long? Let's just say that I only want if let's say if input path is input txt and a and absolute ax minus bx is less than 100, I guess, then I just continue also. A. Wait, but why is A in 64s? Hold on. This is compressed coordinates, right? V's. Why is my V's like this? Because this is index of, right? This is supposed to be int 32. Wait, it is int 32. There is a type error somewhere. Because absolute, yeah, I need to, yeah, okay, absolute. Let's make this generic. Generic T, X is T, right? Oh, but yeah, but how do I do generic 0? That actually, you know what? Let's do this. T as 0, T as 0.0. Fine. Can't cast into error. Const 0 is self 0 self. Implement int32 as 0 to be 0 is 0. Implement int64 as 0 to be 0 is as int64 0. Is that what I do?
Hello, Gawley.
I type here. Okay, that work? There's still a couple errors there. So this is absolute tx returns t, right? No. Wait. T is not equal to int64. How so? What a cursed problem. The bug was that I was simply ray tracing without checking if the edge of the rectangle cuts through the red tile edges. I see. Why does this not work? This should work. What if this is a const? Like it should be just t into t, right? It says that t is not equal to int64. What if I call this apps2? Because I'm not using it then, right? So it's not the other parts that are doing that. T as 0. T as 0 is supposed to be 0 is self. You would expect 0 to be you would expect 0 as t. Its type as trait. 0 binding t. This is correct. 0 has type t. And this has type t. Everything here has type t. Wait, where is x is in 64 even coming from? Hold on. What if I return x here? Like that works, right? If x less than x, then x else x. This works, right? Oh wait, it's yeah. This over here 0. Because this 0 is still in 64. There you go. That's bad. So I need to say that 0 here locally is this. It makes sense, right? It's because this is inferred to be in 64. So like everything must be in 64. Makes sense. There we go. Make this absolute now again. This should work. So this compiles now, and let's see if this is going to, let's see how long is this going to do. I also don't want to print the map for the actual thing, right? So if input path is example, only then I want to draw the map. Okay. I want to just do some progress here, some progress bar, right? So yeah, let's maybe do somewhere here, right? Let's just do over here. Print. Trying. plus toString plus, let's see, let b is uncompressed b, toString bx plus space plus comma plus toString by. Right, so that's like just my point here, and then over here print, let's do this here, right? Print trying direction. Did you make the SVG? Yeah, I did, which is why my thing is a little bit better than like than horrible. Yeah, we have the SVG here. I mean, making the generic solution is not too difficult, but because my interpreter is really slow, we're already going to wait for eternity, so... And trying direction plus toString direction. Okay, and then over here, I want to say y, right? Plus equal direction. Maybe I should instead like say x here or something. Print x is plus toString ax plus slash plus toString bx, right? Because we stop when we reach the b on x-axis, right? So it's something like this: 1 out of 4, 4 out of 4 here immediately, but for the actual input is going to be different. Yeah. Okay, do we start? Do we actually start part 2? Input txt. I need to do it like this. Let's do systemd run. Just in case. Never mind. We just do that. I was just like trying to limit the memory there, but whatever. Okay. And while this works, we can make the solution actually faster by actually implementing arrays in the language, right? So that creating the empty map would not be the slowest thing ever. Right? That would be nice. Have actual arrays. Let's see. Implement arrays. Fine. We got to day 9 without arrays, right? So I should have timed it. When did it start? At like 59. Okay. 259. 2:59:0 is when we started running this. This is the time of this stream, right? Okay. After 9 days without arrays, do we really need them? I mean, how do you do this without arrays? Like, can you do the complexity that is less than, like, in order to not be waiting for this long, I need it to be like, my language is like 100 times slower than it needs to be, right? Because of the interpreter. So when in a normal programming language, you would be able to do like 10 to the power of like 8 operations in a second easily, right? We can only do like, I don't know, we cannot do much. So this over here is creating this is just creating a 2D thing, right, of size 750 times 750, right? So we do this many operations, but we also do it like the actual complexity is logarithmic because we're using trips, and trips have pretty high constant, so it's like something like 4 times math.log. What is log? Is log like binary log? Is there log 2? There is log 2. Binary log of 750, I guess, right? So we do this many operations right now to create the empty map, which is a lot, and these operations are still pretty big. Yeah, this makes sense why it's really slow here, right? How do you do this without arrays? Is there like an actual linear solution? I feel like for this specific input, there could be like an actual linear solution instead of quadratic, right? The only reason it's quadratic because I'm actually drawing the map. For what? For this advent of code. Day 9, part 2. Like all I do here is I'm trying to like go up to the next point. Go to the right if I'm right now not inside of the thing. Maybe like I can somehow check that I'm inside faster. I mean, I don't need to do that because of the way this thing is shaped. The only reason I need to go to the right like I just iterate over the edge here, right? And when we go to the right, then we actually go to the right, but we go to the left, we don't go to the left. That's all that we need to do, I think. In this case, yeah, that's what it seems like. This could have been linear. Your finish is half a second. Yeah, but you are programming in a real programming language, which is compiled, probably, right? Or like even if you are using Python or JavaScript, whatever, their interpreters are really fast. Not my interpreter, right? And I'm using trips where you should be using lists. Done drawing edges. Now we are going to fill the map. So this is another like this feels like this over here is really even slower than creating the empty map. What am I programming in? I'm making my own programming language. And I'm using that to solve the advent of code. So I have the interpreter, but the reason like so if you are interested, the interpreter of my programming language is not intended to be used as an actual interpreter. We are supposed to be compiling this language, but it is not done yet. The interpreter is supposed to be used to derive compile time evaluation only. Well, I mean, you can run it, but it is expected to be slow basically because it needs to like support a lot of like things that you normally don't need at runtime. So there's a lot of indirections going and stuff. Which is why it is slow. And it's also using a lot of RAM. Well, I mean, right now I'm only using like, well, I mean, it says that it's used 12% of RAM, which is basically 3 gigabytes. It's using 3 gigabytes of RAM right now to just store basically a 2D array of integers of a size 1000 by 1000. Yeah. It looks like it's like more slower than 1 a second here. So if it was 1 a second, then it would be 700 seconds, which is like more than 10 minutes. So we're actually going to wait here for like 20 minutes for this to finish. And then this is not the last step even. Okay, I do know though one of the issues. I can show you one of the issues that I already know. Like over here, right? When I say plus equal in my code, right? Like over here, for example, right? So plus equal is just syntactic sugar for this, I guess, which means that this is going to be calculated twice, which is so it's twice slower than needed basically because of that. What we could do is we could have like you know, like x is this, and then say x plus equal add. That's going to be like faster, a lot faster, I guess, twice as fast. This and that here also. I'm not going to restart though. We can all, but what I should do is do a different desugaring here, right? That's what I should do. So when we have std syntax. So here's my syntax, desugaring, right? When I have a plus equal, this is just, so this is not the correct desugaring, right? Because it says so this over here is an AST, right? And I'm just copy pasting the AST twice here, which is wrong. What we should do instead is we should say let let's do this like pointer or like reference is going to be equal to basically reference to a, right? Like so. And then I say that reference dereferenced is equal to reference dereferenced plus b, I guess. Yeah. We can do that. Plus equal, minus equal. Divide and star. So this should still work properly, right? Cast, let's say x is 0, x plus equal 1, x is 1, x minus equal 1, x plus equal 100, x divide equal 20, x is 5, x times equal 6, 30. All right, I feel like that's working, right? Yeah, I need to, like, when implementing my markers, to make sure that the things don't get used twice there. Unless it's a pattern, I guess. In this case, it's fine. In this case, it's fine. Let me do over here underscores. Just because I don't have my macro hygiene is not implemented yet. So this can override local symbols. Okay. Better implementation of op plus of op equal, right? That's good. What's my progress? 130. So we are 10% there, maybe. Okay. I feel like I still want, just in case, to have a look at my RAM. I should not be using more. I shouldn't be allocating more there. But what if I have a leak or something? Okay, so we want to implement arrays. Do I want anything else before arrays? I feel like I also really wanted, yeah, the unary operators, right? What I want unary ops, right? Unary plus, unary minus. Unary plus is useless, but I feel like I still want it. There is also unary operators and like mod. Maybe any other like primitive operations that we want. Bit operations. Do we want bit operations? Do I want bit operations? Any other like basic things that I want on integers? Bit ops are fundamental. Yeah, but like, do you use them a lot? I feel like I never use them. Like, literally never. They are used as optimizations, though, sometimes, I guess. So it's nice. But like, when I actually write programs, I never use them. What do you use them for? Like, you can use them as an implementation detail of like a set, for example, by having like flags, like every bit means some flag. But I would never write a program that just interacts with the bits directly, if that's the intention, because that's just the implementation detail. That's an optimization, which is I don't know, like you can create an abstraction or something. But I mean, yeah, you should be able to create such an abstraction, though, for sure, yourself. It's an optimization, but an easy one. Yeah, but like what I'm saying is that you don't do that directly, right? In my opinion, it's bad to do it directly. Instead, you do something like I don't know. Is there like a crate for it in Rust, like a bit set, for example? Bit flags maybe. Bit flags. Is that a crate? Generate types for C-style flags with ergonomics APIs, right? So like doing this, writing this by hand is something that I don't want. Seems like that's what this crate is trying to make you do, though. Like this is the API that I understand, you know? You just have the I mean, but this is the bit operation. I don't know if there is a good example of I create Rust crate for bit set. Maybe just literally bit set. A set using bit vector. Just like insert 0, 3, and 7, right? Like this is implemented using the bit operations, but you don't, like, you just say contains 7, right? And then you have like a wrapper around this, which actually, like, instead of numbers, you just have like normal enum, right? It's like I guess like what I imagine in Rust, but I never used such a thing, is that you would have an enum, you know, flags, and you have like flag A, flag B, flag C, and then you just derive bit flags or something, you know. And then you would be able to write code like flags is flags bit flags, for example. I don't know, like, what should it be called? And this is basically like a set, right? And then you say flags, insert flags A, which technically is just compiles down to like flags or equal like 1, I guess, in this case, or like 1 shifted to like 0, basically. What if you need to precise bits for external stuff? I don't know. I feel like it's still like but like you do it once still. Like I feel like it should never be present in user code. Sure, you write like a wrapper for the FFI, but I don't know. I don't like exposing these implementation details, optimization details. Like when you talk to C, yes, you create a wrapper which is safe, and which is more difficult to misuse than just interacting with the flags directly. That's my point. Because if you expose this implementation detail, then you can fuck it up easily, right? Okay, but we should still have them. Yes, I agree. I'm also thinking that because I don't use them a lot, I feel like they should not be like the operators. I feel like there is no need for having an like operator A vertical bar B, right? I use this vertical bar for other things. If you really want this, maybe we can have you know, I feel like it should be like a keyword, you know, like bit or. For example, I could see that. So you want to implement a communication protocol with some telephony hardware or board navigation or whatever. Yeah, I mean, yeah, I feel like you still want. I mean, you mean implement the communication protocol. If you want to use that protocol like in a bigger program, you want to abstract the protocol away, right? I mean, there will be a like this thing as implementation detail. I'm just saying that it should not be leaked to the user. In that case, to the user of the communication protocol. And inside of the communication protocol, sure, if this is like small enough piece of code, then you can use the bit operations there, I think, sure. But having bits as part of public API is weird, I think. But I don't know. I mean, I don't work much with low-level stuff, right? You never like the separation between library author versus app author? Hey, T2SD, thank you. Hello, hello. Thanks for the raid. All right. Welcome. How are you doing? We're just right now waiting for my program for the Advent of Code Day 9 Part 2 to finish running. So what I'm doing here is I'm solving the Advent of Code with my own programming language, and it is being interpreted right now, and it's really slow, my interpreter. So so we're waiting for like 20 minutes here, where in a real programming language it would take half a second. So yeah. And in the meantime, I'm improving the language. So for example, one of the reasons it's slow right now is because I don't have a raise, so I'm going to do that. And also I'm doing the some extra operators, I guess. So we are going to add unary operators, unary minus, and the modulars operation, and we want a bit operations. But yeah, you said you never liked the separation between library author versus app author. But I mean, it's not the separation between library author versus app author. It's just creating an abstraction without leaking implementation details. It's called encapsulation, right? It's what you like everybody does that, right? It's just where do you draw the line of like what's okay to expose and what's not okay to expose is the only difference, right? Like, for example, Zig, the programming language, one of the things that they say is that every field in every single type must be public. So that any code that is interacting with a type should be able to read all of its fields, even although there are implementation details. So in my opinion, there should be the distinction between private and public fields in your structs, right? How do you think? Okay, let's start with a simple one, which is the unary operator, right? Unary operator. I need to go to the default syntax rules. What's the priority of the unary minus, by the way? Should the priority of the unary minus be where? It should be pretty high, right? Should be higher than this, higher than that. But it should be lower than generics, right? So if we have in code something like negative what about applying a function, right? Negative fx, right? So normally in your programming languages, this applies to the result of the function, right? But because we can apply right now functions by just doing that, that's not going to work, and we will need to put the parentheses around functions if we do something like that, right? But who are you to decide what is my abstraction level? Well, I mean, I guess it depends on the use case, but maybe like like, I mean, if we talk about like this, which is the public, like all fields should be public, right? Like, I mean, at some point there exists an abstraction level where the things should not be like should be like kept as an implementation detail, right? So private is good in that case, right? Yeah. And similar to that, like when you are like when we work with any other things, I'm not deciding what your abstraction level is, but there, like at some point, you're abstracting like but like at some point your abstraction level becomes like what's the word, like big, so big that hiding the implementation detail makes sense, right? But if it never happens for some reason because of the program that you're writing, then yeah. Okay, so we want to, it seems like what I want here is to have the priority of the unary minus over here, maybe like 65. So we have minus x minus underscore. This is core unary. Wait, it's not core. It's not core. It's just unary minus. And then unary plus, because I like unary pluses, even though it's useless. We're going to have that too. We're going to implement this in the std syntax. Here, I'm going to implement syntax negative x as what? A negative x is just std. Let's put all of these math operations next to each other. I feel like that makes sense. Yeah, so negative x is just std op negate x. And let's be a restart. Field negate is not there. Wait, but where? Char 19. Wait, now this is parsed as this being the unary operator. So yeah, this is now being parsed as me trying to call the function chart code A with this being the argument. Okay. That's because the priority of the unary operators is higher than the priority of the function application. Wait, is that why? Hold on. Let me do this. Cast parse. Cast parse what? Like f like a plus b, right? There we go. So this is called as, no, this is properly parsed. Okay, what if I say a plus b plus b? Okay, so now this is me adding a to the application of a function a, function, I guess, b, applied with a unary plus c. Okay, yeah. Is it because my priorities are wrong? We are 50% done here, it seems, at the advent of code. Okay, syntax. So my function application is priority 50, right? But I mean, when I see code like wait, I can make the unary operators to be lower priority than the function application. Then negative fx will be parsed as right now this is parsed as negating the function and then applying the result of negation with argument x, right? But that doesn't even make sense. So maybe like it should be lower than function application. But there is also something else here. Like there's the returns, for example, right? So right now, if I try to like return negative x, that's going to work. But if I make, wait, but why? Wait, why is my return higher priority than the function, right? Because I want to like return fx, and right now this doesn't work. Because what this is being parsed right now as me returning f, and then applying the result of me returning f with argument x. That makes no sense, right? I'm just having all of my syntax messed up. So let's move the return. That should be below the function application, right? This should be I'll do 40 here. Function application. What about unwindable token body? I feel like unwindable token body. It was 60, right? I feel like this can also be moved, and with return, all of that can be moved. Let's move all of these to be 40. See if my code still parses. And then the unary operators are going to be just higher than that, but lower than function application. So like 45. Unexpected semicolon at std syntax 48. 48. Wait, what's the problem right now? Unexpected semicolon at, oh wait, at syntax 68. 68 is this, because this is unwindable, a loop body, semicolon there. The semicolon is unexpected, but why not? Why not? So I want to parse, let's see, unwindable block body semicolon, right? So this says unexpected semicolon. And this says unexpected end of file. Cast stop on first error false. Stop on error false. So it we have error, unwindable ident, because it's trying. Okay, I see. Yeah, because now it's thinking that this is the function application here, right? Of this, with this being the argument, the body. Okay. Well, I mean, yeah, rules, default rules. So unwindable should not be moved then. Or I can say that the body is always enclosed in parentheses. Is another thing, because this looks like function application here too. Unwindable. Let's make this to be back at 60. Cast semicolon syntax line 73. Then now it says unwind this and that. Yeah, because unwinding. Okay, yeah, that makes sense. So I should undo that one too, right? Unwind. What about with return? I feel like with return can also be moved back. So I just move the return up then, right? And these are going to be same as before at 60. Cast. Okay, it seems like all of the standard library is sparse, so it's probably good enough. Okay, so negative x, negate field is not there, could not find x in scope. Yeah. Let's see negate, right? So if I go to the standard library, standard operations, right? I need to have a new thing which is called negate. Should it be called the neg? T x t returns t, right? So this would be this would be cfg if target name is interpreter, then so this is a native one, right? This should be a native unary minus x, right? Is there any like any world where the plus operator has a meaning? Is there any programming language where unary plus means something? So like it actually, yeah, in the JavaScript it converts the type, right, to the integer, right? Like I just don't want to implement plus x as returning x, because it should like still at least like check that it's like something for which math makes sense, all right? So it should still go through a trait. But what's it called? What's it called in Python? How to overload it for my own type in Python. I'm just wondering what's it called there, like underscore pause. Yeah. So it's just pause operator. I mean, maybe it can have a meaning. Like, you know how in floating point numbers, like -0, -0, and +0 are two different things, right? What if there existed a thing where like there was also a 0 without the this sign, and it's like a third option? Does that make sense? I don't know, probably not, but I don't know. But -0 also does make a lot of sense, right? But it still exists. All right, let's have a const pause. I'm still going to implement it though here as the thing, as x, but we will want to check that it we'll want to check that it implements the trait later, right? Okay. Negate is going to be called neg, like this, right? Okay, so if I do cast -1, now I need to implement the native one, right? Natives interpreter. Boom, 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 boom. Negative. I mean, this one should be native, right? I mean, technically I can implement it as 0 minus the thing, but then I need to have a polymorphic 0 or a trait 0, right? But yeah, no, it should be native. So we have a native function called unary minus. Unary minus doesn't work with value print value. Wait, what is this? This value shape print value. Okay, so what does it work with? If we have a value int 32, then x, then we should return value int 32 with int 32 dot neg x, right? If we have an int 64, then it should be an int 64. And this should be int 64.neg. And I don't have floats yet. Oh, yeah. Maybe that's what I also do at the same time. I can also do the floating point numbers. Floats, bit operations, mod operator is like faster. It's 600 out of 750. Okay, it's almost done. There is more steps though after this, right? Yeah, there's more steps. The other steps are faster though, are they? Yeah, I think the other steps are actually faster. We're almost done. Let's see. Cast -1. -1. There you go. We actually have the -1s now. +1. Must implement rule before using it. Okay, syntax ks. Implement syntax plus x as operator plus. +1 is 1. -1 is -1. All right, nice. And if I have let x be in 64 as parts 1 to 3, right? Std string like this. I need to like also like this is another thing that I should change, like types, and this is like a module, I guess. I need to like be able to merge them somehow because this is a little annoying. And to figure out how to do that. So -x is still working. Okay. This is just unary minus and plus. Is there a function not? In standard library, by the way, because I have been implementing that. I don't have it. Yeah. That's another thing that I could do. Do a not function because it's implemented right now in my inventive code, right? Let not. It's just a function. Should this be a keyword or should this be just a standalone function? What's the advantage of this being a keyword? Like if I say, for example, fx, and this is a thing that returns boolean, and if I say not fx, then right now this is parsed as not fx, right? But so which means that right now I need to do the parenthesis here. So if it's a keyword, then I can like change the priority, right? Like in C, you just say if not fx, right? You don't do the parenthesis here. That makes no sense, right? So I think making this a keyword is actually Yeah, I like that. I do like that. I can do this purely in the language though. Just do syntax rules. What should the priority above this? So like lower than the function application. Lower than the unary operators. If not, A is equal to B. That's something that I should be able to write. Yeah? Like not 1 equal to 2, right? Should this be parsed as not 1 equal to 2? What about Python? Not true, right? So if I say not 1 equal to true, but is it because not 1 is equal to 2? It's no, yes. So that's actually how Python is doing it, right? So I feel like I should do it the same way. So before the comparison, then what about ORs? But it should be higher priority than the AND operation, right? Because if we say true and not false, right? Then yeah, that's what it means. So yeah, I should have syntax not 12, I guess, priority, and then wrap, just never wrap, I think, here. And then we just should this be associative? No, it should not be associative, right? And the plus and minus is also not associative, by the way, which means that negative x does not parse for me right now, which is it should not, right? Not. So just say not space underscore, right? This syntax implement syntax not x as just I can just implement it like if x then true, then false, else true, right? I can do that. Not true, false, not false, true. True and not false. True and not true. Okay. True and not true. Parse. All right. Okay. Yeah. Good. Not operator. Good enough. Okay, mod. So mod normally in language like C is the percent operator. I'm not sure if I like the percent operator. We can have mod being the keyword too. Another thing that I don't like is that that the division operator and integer division is the same. So I feel like I want to do it as Python, where the double slash is the division of the integers. Should probably do it as early as possible. Wait, hold on. My advent of code is calculated, guys. Do you think it's the correct answer though? Do you think it's the correct answer? Well, it's a 50-50. It's either correct or not correct, right? Ah, shit. My answer is too high. No! We need to wait for like 1 hour again. No. Wait, why did it stop at X 352 out of 680, 649? That makes no sense. That makes no sense. Wait, no, it does make sense. It does make sense. The reason it does make sense is because this is the center of the circle. Wait, am I like... is my solution not correct? So like this over here has X 649, I guess. And this over here in the middle, which is like the highest point that we can go, is just X 350, which makes sense, right? Have I tried going up and going down? Trying direction -1. I should try this twice, right? Trying this point. So this point, and then I was trying one more point, right? So I actually tried 2 points. Correct? Yes, I tried 2 points, which is these 2 points. Is this not the correct thing? Is there like some other... thing? My answer is too high. Oh, wait, I understand though. I understand. I'm stupid. It's because... because I did not calculate how high up can I go. Oh my god, we actually need to wait. I know the bug. I'm stupid. Over here, I need to like because I let's go in the y direction. Up to the very top, right? To over here. But I should only go, and not more than where we were going, where we can go on the right side, you know. So yeah, I should actually like stop very early. So that last step is going to be really, really fast. Yeah, that makes sense. Let's fix that. Let's fix that and wait another 20 minutes. Try and direction this. So I should just say that the y at which we should stop is what? So I should go in the same direction in y, right? Yeah. So so maximum y is by, and then while map at bx and max y is not 0. We need to max y plus equal direction, right? So when should I stop? I should stop if ay. Well, I mean, max y is already like, we can do max y minus equal direction. Then it's actually the maximum and not the one that should not be counted already, right? So if ay is less, so if ay, if max y minus ay times direction, I guess, is less than 0, then I also break, right? So this means that max y is less than ay already at this point. In case we go in the opposite direction, it's like the opposite sign, because then it's like the minimum y actually. All right, let's run again. Wait, how long was that? When did I start? Is it actually 20 minutes? Wait, but if I'm restarting, let's actually like make it twice as fast, right? So this step is fast, I'm pretty sure. So what step is not fast? The step that is not fast is well, creating the empty map and then filling the map. Filling the map is the difficult one, yeah. Over here. Cell is this, you know, so that we don't calculate it twice. Almost an hour? It was running for almost an hour? Oh shit. Well, I mean, I have stuff to do for 1 more hour, right? We can implement like all of these things, although I don't know, it should not take that long. I mean, erase might take long, so yeah. Okay, we'll wait. I think this should be working. Let's see if it's going to be a lot faster with that optimization, taking the reference ones or not. Maybe it's going to be like instead of an hour, half an hour then. Okay, I want the mod operator, right? And yeah. Do we like the percent operator? Or do I want it to be a keyword? I don't know. Maybe it's okay as an operator. And we also should have the percent equal then. So there should be like percent. Right? And then syntax percent is going to be mod AB, right? Like that. Syntax rules divide. I should have the percent and percent equal. Mod assign percent equal. Format request failed, no matching language servers. I don't know, I feel like this is a bug of Neo Vim though. I literally, hold on, LSP info. Like I have the language server, right? Cast. And my language server can do formatting. Why can the Vim not figure out that I can do the formatting? That's stupid. Okay. std op. We will have the mod here. Mod. Native percent. Okay, natives. Bin op percent int32.mo dot. Oh, it's called rem, not mod, right? It's the remainder. How does it work even in OCaml with negative numbers? One mod 2 is 1. 11 mod 2 is 1, right? Negative 11 mod 2 is negative 1. Is that the operator that we want, right? Negative 11 mod 5 is still negative 1. Yeah, makes sense, makes sense. Okay. Sure. Okay. That's the mod. I mean rem percent. Let me actually call this rem instead of mod, because module is a different thing, right? Remainder versus module. Remainder is simply the remaining part of the arithmetic division, whereas modulus is the sum of the remainder and divisor when they are oppositely signed and remaining part of the arithmetic division. When the remainder are both of the same sign, right? So that's the difference. Yeah. Is this faster? I feel like this is not faster, but okay. Rem operator. Okay. Floats, beat operations. Let's do beat operations first, actually. Maybe I don't even do the syntax for them. I don't know. Like definitely not the vertical sign. Std op. Just have the functions for now. So what are the bit operations that we want? We want XOR, right? We want let's have like bit, which is a separate like module. So it's operator bit bit end, bit dot end, maybe. So end t a t b t t end. Oh wait, hold on, I cannot call it end, right? Okay, whatever, then I don't do the mod. Let's do bit end, which is going to be target name is interpreter, then native bit end AB. Okay, what else we have? We have a bit OR. Then we have bit XOR. What else? Bit negate, I guess, is another thing. Bit shifting. Bit shifting is something that let's see, binary bit waiters. Bitwise operations in C. Let's see. Bitwise AND, OR, XOR, left shift, right shift, and NOT. Well, it should not be neg then, right? It should be bit not. Bit not. Not. AND, OR, XOR, NOT. And the shifting. So they don't have like the actual shifting, which is like what do you call it? Like cyclic. Isn't there the operation in assembly that does this cyclic shifting? Assembly, bit operations in assembly. Where's the spec or something in x86? x86 assembly guide, assembly and byte instructions. Wait, what is this? Cookies? Wait, is that all? Bit and byte instructions? Individual bits and operands? Where's the shifting? I don't see shifting here. Shift arithmetic right without affecting flags. Shift logical. So there's logical shift and then there's arithmetic shift, right? What's the difference? And why can I only... Oh yeah, there's rotate and then there's shift, right? So shift just adds zeros in place of the thing. How do you do rotate in C? Do you implement this using the shifting operators and like ORs? And it's and you're expecting the optimizer to fix that for you? How do you do bit rotation in C? Right, you do that, but is it optimized to a single instruction then? So they will emit a single roar. Like, why does C not have this as a built-in thing though? Anyway, I feel like what I'm saying is that we should have both rotates and shifts. Your compiler isn't feeling dramatic. Yeah. Hold on, I was also... So like there's also logical shifts and arithmetic shifts. What's the difference? What's the difference between logical and arithmetic shifts? Logical shifts shove bits over and drag in zeros, like a well-behaved belt. Arithmetic right shifts though, they cling to the sign. Oh, I see. So you keep the sign bit Bit shift right, but the sign bit is copied instead of 0. Positive numbers pull in zeros, negative numbers pull in ones. I feel like when you work with bits, though, you work with unsigned integers, right? Is anyone using this thing? The arithmetics? What's the use case for it? So what do we do? Bit shift left. Then we do shift right, and then we do what? And we do rotate left, and then we do rotate right. Right? I feel like this should cover all of it, right? Do I even have these operations in OCaml though? int32 dot shift. Yeah, there's shift left, shift right, and shift right logical. Well, I don't have the unsigned integers. Yeah, maybe I should do unsigned integers. Not Mizu 04 KGB. What not? You don't use it? There is no use case for it? Well, I mean, I guess like shift right is the, like, if you want to divide by 2, you just shift right by 1. And, wait, but does it actually work? Is it actually like division by 2? For negative integers too? Arithmetic right on this is that. It is, right? But -1 bit shifted right to 1 is still 1. -1 is I mean, is this in Python the shifts, the arithmetic shifts? I have no idea. -1, right? Because -1 is just all ones, and if it's all ones, then it keeps all ones, right? Because yeah, it just keeps the flag. But yeah. So this is not division by 2 then. So, okay, what's the use case then? What about -2? What about -4? Yeah, it's dividing by 2 for everything except -1. Am I right? 17 is -9. It's dividing by 2, rounding up. It's dividing by 2 rounding up. Which is why this is still -1, right? That's what it means, arithmetically, then. So maybe still useful. All right. Okay. Is there a rotate though? How do you rotate? You don't rotate. Okay, you know what? We are not going to implement the rotation then. Let's just do bit end int 32 dot. How do you bit end? Oh, there is a log or log XOR. They call it log. Bitwise logical end. That's why, right? It's not bit end. It's bitwise logical end. Log end. Okay, bit or log or bit XOR XOR bit well, I mean bit not is the is like unary stuff, right? So bit not is just in 32 log not. Bitwise bit not. Okay, and then we want to shift bit shift left bit shift right shift left wait, and shift left is always removing the bit then? Like, why is there no like difference between arithmetics for the left stuff? If I say -1, then this becomes -4. Yes. In Python. Which should be which would be just 4 if I forgot about the sign bit, right? Why is there no distinction for left shifting? This is half done. Then extension only matters when shifting right. Left shifts multiply by 2-ish and the sign bit gets blown away anyway. There is nothing to preserve. Wait, but for negative ones. But for negative, shifting negative would make number positive. So in C, -5 shifted by 1 would be like 10, positive 10, right? So Python actually implements that differently. Is that right? Let x be -5, x dot shift left 1, dbg. Wait, what's it called? Rotate left. There's also final shift operations because there these things exist, right? We shift from right hand side into this. Interesting. There's swap bytes, reverses the byte order of the integer. Is that also like a like the built-in thing in assembly? I never used that. Wait, this swaps the byte order of the integer, and this swaps the bits of the integer. Source. What is this, like the opcodes? Okay, anyway. What was this called? Bit shift left int32 dot, just shift left, right? Shift left. Shift left. Shift left. It takes an int here and not an int32. So I should say instead function ab into shift left a int 32 to int b, right? And over here we do int 64. Wait, it's because like bit shifting takes as an argument the amount of bits. Which is U32. So when I'm rotating U16, I can rotate U32. Right? And even if I'm rotating the I128, it still says U32. So this is the thing. It always takes an int32 there. Okay. I'm going to use the same ones for now because I'm too lazy. Yeah, but I should add like all the other like unsigned types. Maybe then I will do it properly. Bit shift left. Bit shift right. This is going to be left, right, like that. Okay. Past. Let's see, std op. So I want bit end 1 and 2. Bit end 1 and 2 is 0. Bit end 1 and 3 is 1. Bit end 2 and 3 is 2. Okay. Bit or 2 and 4 is going to be 6, and bit XOR is going to be 6. Bit XOR 2 and 3 is going to be 1. Okay. Bit not 2, bit not. Okay, hold on. std ops. Bit not is a unary thing, not a binary thing. Bit not x. Bit not 2 is -3. Is that correct even? 0 is -1. That's correct. Yeah. Okay, bit shift left 1 by 1 is 2, 1 by 3 is 8. Okay, bit shift right 8 by 1 is 4. -8 by 1 is -4. Okay, I guess this works good enough, right? Rotating, I'm just going to not have this here for now. This can be implemented using shifting. Okay. Beat ops. Beat ops. Alright. What's my progress here? 540. Almost there. All right, floats. Floats is useful. I'm surprised that I did not need floating point numbers in the advent of code yet. Is there like never floating point numbers needed? Okay, so I have values. Do we even have like double precision floating points in OCaml? Float 32 of float. Like there's floats, right? Is there doubles? There is no doubles, right? Camel double. Module float. Is there floats? Floats are double precision. Is there no 32? I mean, I guess I don't really need them. Right now. Let's just do float 64 of float. Then. Type shape. T float 64. T float 64. T float 64. Wait, how do I switch here? That works. Oh, I don't have float 64, just float. There we go. Okay. Print. If I have a float 64, then I should print should it be just F? Value. I feel like there is specific things for the int32s too, by the way. Print F or camel. Int32. Yeah, LD. This should be just LD, and this should be like capital LD, I guess. Value. Yeah. Okay. If I have a type float 64, float 64. Inference. We just say that if we have type float and float like that, and also value runs like that. Infer value shape. If I have the value of, if I have a type float 64, we don't know the shape here. No. This pattern match is not exhaustive. Type of value shape. I have a value float 64 then it's float64 type. Okay. Substitute value shape. Value float64. It's not substitutable. If I have over here sort of type shape, float 64, not substitutable. Okay, LSP completion for type float 64. We just show the type icon, the variable icon, yeah. And in this transpiler, we just have a to do. That's all. Is that all? Fast. Okay, seems like that works. I also though need to do for the natives all of the things for floating point numbers, right? The binary operator for floating points. So binary operator and unary operator too, by the way. But unary operator is only the negative, unary minus. This one should also works for float. So they should return float64 float.neg, right? That works. If I have the binary operator over here, this should be also float add. This should be a float sub, float mul, float div, float dot rem. Is there a rems for floats? There is. Okay, yeah. So we do that, but then it means that the binary operator. So like. I guess not all of the binary operators have float support, like the the bit operators. So we should say none. None. None and none, right? So binary operator should have the operator float, which is going to be float, float, float option, like that. So over here, I say that if we have float64, float64, we return float64 operator float. Yeah, you're going to match of float with sum of float. If it's none, then the error. But here it can also just be error, right? Which means that I don't need the return here, by the way. Make this a little bit simpler. Okay. And then we just do in the standard library. I feel like this also should be changed. Instead of having this in the std.bool, maybe I should have types is a module where we have all of these, you know? Something like that would make sense probably. To have boolean int, uint right now is still int, sure. In 64, and we have a float 64, which is float 64. Types.string. This is annoying though. Okay, I will do that later. We'll do that later. Let's say to do module types. The reason it's annoying is because I cannot have like private imports right now. Native float 64. No native float 64. Yes, because in the natives, should say in the very beginning, somewhere over here, I have type. Shit, what did I do? I have type float 64 is t float 64. Okay. That's not all. The t int 32 int 64. Let me search where int 64 is existing. Native function int 64 to string. I guess I will need to also convert these things to strings, right? Oh, my advent of code is done. Let's test this. Is this going to be the correct answer? Easy. Easy. Okay, advent of code is done. Just need to like run a program for an hour. That's okay, right? That's okay. J9 part 2. Okay, but I mean, we can now that we have these solutions, we can actually like once we have the compiler test the thing on these solutions and see that they work fast, that they will work fast eventually, right? Yes. Why don't I have just a function that is called parse or stuff, you know? Yeah, let's do that. So like there's either a toString, right? Which should be spin not inferred span. Okay. Let S be. Integer string, and in this case I will actually return. Let's do with return value Use shape. In this case, I'll return the error, and then I will say this string s. Then we do this into value in third span. Oh no! Oh wait, it's missing. Oh, that's not with return. Where's the syntax error? Hello? Line 561. Nope. Nope. Line 452. Right here. This match is unmatched. Oh, this one. Like this. Okay. What do you mean error.error? Unbound module error? What do you mean unbound module error? It was bound before and now it became unbound. This stupid OCaml. LSP restart. Why do I need to restart the server? For OCaml to work? Okay. If I have int 64, if I have float 64, then I need to do float. If I have char, then it should be char to string. Char to string. Is that not a thing? Unbound value char to string. Char dot. What do we have here? We don't have anything. We can do string make one value, right? I guess that's how we do it. If I have value boolean value, then we can bool to string. Well, I mean, I can implement this for everything technically. ToString doesn't work for I'm tired about this. Let's go back to VS Code. The string doesn't work for this. Unbound constructor v error. Did you mean error? No, I did not mean that. Are you stupid? How many type annotation do I need for OCaml to actually work? Okay. What else? This is ToString, and then this over here is going to be parse. Right? Oh wait, but for parsing it is not working yet. Nah, I need my natives to be like a little differently now, to work a little differently. ToString. So int64 to string is supposed to not exist anymore. To string. So we just have a single to string, which should work for every type, kind of. in 64 to string. Adjust this. I'm just going to say natives to string here. Does that still work? Let's see. Cast std string to string 123. Type doesn't have fields. Capital string. Okay, that works. And if I say std string parse 123 of type std in 64, and still works. Okay, nice. Yeah, it's supposed to work. Good. Yeah, it's just like I need to parse float. If I need to parse a float, then it will not work. But the way I do this is my natives. So native is a thing that can be polymorphic over the type, and like whenever I like when I query the value of a native, I should, yeah, so like natives is just natives, right? Which is types natives, right? Types natives is just by name, we have values, right? But this should actually be by name. This should be a function from type into value, right? So what is the type that we expect? And based on the type that we expect, we can give a different value, right? Is the thing. Let's just say that I have implemented floats though. It's just like I have no way to create a float, kind of, right? Because I cannot parse it from a string and I cannot cast. Casting is one of the things that could be done as another thing, I guess. But that also requires like either like dedicated functions or actually, you know what? Let's actually for now, before I check this, string to int 32, string to int 64. Let's actually for now copy paste and say over here, instead of int 32, all of these, I want this to be float 64, right? V float 64, v float 64, float of string opt, right? Like this, and that will allow me to do that. I will also be able to do in string ks over here, right? I can implement float 64 as to string. I can implement float 64 as from string to int60. So like, yeah, this one are just polymorphic to strings, and this one has dedicated ones, right? So this means that I should be able to just say 1 2 3 parse let x be float std float. I should make the prelude be available by default. Use std prelude star let x float 64 is 1 2 3 parse, right? Float 64 is not found. Cannot found float 64 in scope. Compiler error. Because it's not exported from the prelude. I need to do std float 64 right now, and this going to be x is 1 to 3.0. Nice. Let's just add this to the prelude. GJ, hello. It's nice that you're talking out loud. Yeah. It helps me understand what I'm trying to do better too, I guess. And the fact that I'm doing it to this stream, and like, I mean, I don't do it off stream. That would be weird, right? So doing it on stream makes it an excuse for me to talk to myself sometimes. I guess. So load 64. I wanted to add this to the prelude. I just use float 64, so it's always available, right? Let x, yeah, and then yeah, that's going to be floats, right? Maybe I don't do arrays today. Maybe I don't do arrays today. We solved the advent of code. Let's instead just do like this last thing, which is like polymorphic natives. This is going to be useful anyway, and remove the code duplication maybe a little bit. Float 64. Wait, I did not try like adding the things together, right? But it should work, right? If I say let x, let's first make the prelude be implicit. The prelude be implicit. Should the prelude be implicit always? Like, because I still, when I'm writing my code for the advent of code, I'm still saying use prelude, right? Like, should this be just always implicit? And but we should be able to like opt out of it then, right? But maybe like opting out of it can be done later. I feel like opting out is good, right? Even I'm working on my own language so I can understand the deep dives. Nice. What's your language about? Any links? Do you import the prelude implicitly or explicitly in your language? I have still like the std as a symbol being available. This is the only thing that is implicitly loaded into the interpreter, into the language, right? So std is the only thing that is implicitly available. But I feel like using std prelude would make sense. Harnet lang. So what does harnet mean? Hello? Hello? Is it working? Name of my daughter? Huh? Huh? I don't know how to see it. My internet doesn't know about it. Maybe it's a language from the future that I cannot connect to yet. No DNS for you. I don't know. I tried both and with and without the VPN too, which is weird, right? Then does it work for you? Harnet lang. What if I Google it? Leighton lang. Can I try this? This worked. Wait, what's different? Oh, Harneet lang. I see. You just had a typo, I guess, right? That makes sense. All right, you have a video and shit. Okay, that's okay. The website is a lot better than mine. Made with love for developers. Okay. 80% of Haskell's functional programming benefits with 50% of the complexity. All right. I don't know why did I read the literally the last thing first on the website. It adds imperative programming flexibility and maintains the benefits of type safety. Does it now? Is it still like monads under the hood and like whatever? Let's see. Let's see this. You have a search. You have printing. All right, databases. Okay. Seems like you don't have types here in your code, so it's all inferred or something. Var and this and that. Wait, hold on. This is Go. Am I on the correct website? This is pure Go. There's no like wait. Like I mean I mean yeah, but like when you said Haskell there in the bottom of the page, I did not expect to see if there is none. Okay, it is not Go because it's not a nil, it's none. Okay, but I did not expect that after seeing the word Haskell. Okay. Nice. Linter and auto format. Runtime ready. Simple syntax. Zero cost abstractions. Is it zero cost? Actually. Type safety means flexibility. Any type from control flexibility. Wait, you have any type and you have zero cost. Does that even work together? Functional programming, first class functions, higher order functions, type safe functional programming, strong static typing for functions. Yeah, but when you say Haskell, like, do you support higher candid types, for example? Those cold examples are old. It's inspired by Go, but it has pattern matching enums and other advanced features inspired by Rust. Yeah. I don't know. Maybe you should remove Haskell here. At least, like, I mean, that's my first impression. I feel like maybe you should like do Rust functional things without the Rust's complexity, for example. Our need combines the power of modern programming language with the simplicity you need in today's software world to get started. You should be working on your app, not figuring out borrow checkers and async programming. Yeah. Completely opposite goals from my goals, I guess. I mean, I say that I should be working on my apps and not writing if error is not nils all over the place, I guess, or something. Figuring out borrow checker is a one-time thing anyway. Like, so it helps you to work on your app instead of debugging some seg faults or null pointer exceptions. So I don't know. Yeah, I agree with the fact that you should be working on your app, but the other parts are completely opposites, I guess, for me and for you. Get started. Just REPL. Just build. Is it built in Rust? The language? Where's the source code? Is there a source code? Ah. What's the extension for this language? Just hi? It has a REPL. That's nice. List current variables. I should be able to list current variables in my REPL, by the way. That would be nice. Core types. Runes. Wait, hold on. These runes represent Unicode count points. Should I... So, like, instead of char, you say rune. Should I rename my chars to runes? What's the reason for that? Char or rune? Pick rune. But Rust uses char. So is Rust's char a rune? Exactly what a Go calls rune? Does Go has chars? That's why you call it rune, because it's Go based language. Does Go have chars? I thought for some reason that Go has chars too, but I guess I never really written a single piece of Go code. Unicode Scholar is rune and Rawbyte is byte. Pipe operator. Nice, nice. Value into function AB becomes function value AB. How do I go to the main website now? From the docs. Downloads. Build from source. Where's the source? Build from source. GitHub Hornet Lang. Okay, there we go. It was difficult to find the link to the source. Is there any links here? I guess this. I did not. Okay, this does not look like a button to me, but yeah. Real world examples. Wait, where's the language itself? Why is it not pinned? Wait, what? Didn't I just clone it? Oh wait, 404. Wait, there's the thing in your documentation is 404ing. Oh, you're not open source in it immediately? Okay. I see. I mean, the website is nice. If you are targeting people who like Go and stuff, then it's cool. Yeah. But we do have like opposite opinions, I guess, on what on like this thing. Yeah. Looks nice. The website is cool, I guess. You're just missing the syntax highlighting here, which I'm also missing. Does Go have REPL? Is there a Go REPL? Go REPL? Oh, I mean, like a separate project. You don't know how to do that? How to do syntax highlighting? Do you have your language server or not? Wait, do you have language server? I did not see that. You have your tree-sitter grammar though. I saw that in your repositories, I think. Right? Isn't there tools that convert your text with tree-sitter to like HTML? I'm doing my highlighting myself. I don't use tree-sitter. I mean, it depends what you build your website with, I guess. Maybe they can import the grammars. I just have the like for me, I just have like this stuff. I guess over here. I can just highlight in the terminal like this. I need to add though here the HTML stuff so that it actually highlights, and I can and then I put that into the thing. But I don't do tree-sitter. I have a custom stuff. Or TextMate. I feel like there should be tools though that should just be able to import. You're just using some static website generator probably, right? I'll use AI to build the site. You're not a fancy web developer. Well, I mean, I'm not either. But what did you use? Like, no, maybe like Hugo or something. Hugo Go. Go Hugo. Is that what you use? Maybe I'm not sure. Anyway, nice. Nice job. Nice job. React span. Okay. All right. What am I doing now? I was doing something. Polymorphic natives. Yeah, that's what I wanted to do. That's what I wanted to do. I do think though that you should remove the word Haskell from the website because it seems like it's too different from it. Right? Like your type system does not have like HKTs and you cannot do monads, right? Mm-hmm. Like I feel like even if a person who is like liking Go and like simple languages like that, they're going to just see the word Haskell on the website and look away. And then the people who like Haskell are going to, on the other hand, expect something more, I guess. I mean, I did not look too much to the language. Maybe I'm misunderstanding something. What did I want to do? Polymorphic natives. Okay, so we have natives here. They should basically be functions from types, right? So types. The code examples are all the newer versions. You do have concrete ties. You don't have monads. Do you still have if error is not nil? Type error checking. Do Go people actually like that compared to like the other languages who do it differently? Like Zig is another language which is considered simple, right? And they don't do if error is not nil. They have the try keyword instead. Types. Natives. There we go. This is what I want. Natives is going to be by name. This is going to be type into value. That's all. Type into value string map. There we go. Act cannot be derived. Yes. Equal and compare is just this. If error is not none, I think Go people like it, even though it can become verbs at some point. Like I didn't write a lot of code in Go, but I did write a little bit. And in the one that I was writing, the if error is not none and like this stuff was taking 90% of my code, and there's only 10% that's actually logic, which is why like I don't know. It's not very verbose. It's very verbose. So yeah, I don't know. I don't like it at all. Like Rust's question mark is verbose. So yeah, natives is just type into value. Given the type, we can get the value, but we need to give it the type. All right. You like it since it differs to the dev what they want to do with the error. If you don't want to use it, you can always have the blank identifier. Well, I mean, that's true for the Rust error handling too. It's true for Zig's error handling too, right? They all defer to the dev what they want to do with the error. But a lot of the time, you just want to basically forward the error to the caller of your function, right? Which is why in Zig it's easy as just using the try keyword, and in Rust it's the question mark. It still is explicit in those languages, right? You know, Camel here, we don't do that. It's just implicitly there, the exceptions. I can see how we can not like that. And I mean, I'm not liking the fact that they are not present in the type system, for sure. But yeah, if you don't want to use, you can always use the blank identifier, but that means that you are just ignoring the errors, and that just leads to incorrect behavior, right? Looked at your language, what pushed you to have so many parentheses? What would you prefer? It's not as many parentheses as in the Lisp, right? It still is your normal amount of parentheses, I think. What's different in this, in the amount of parentheses compares to your normal language? The only difference is that your languages use curly braces instead of round brackets. But other than that, there is the same amount as you would normally use, right? I wouldn't say that I have so many parentheses. If the question is why I'm using the normal parentheses instead of the curly brackets, then why should we use the curly brackets? That's the question. I'm open to discussion here, but like, this is an expression-based language. Everything is an expression. If you want, like, the reason for parentheses is to basically just change the priorities. You would expect indentation blocking. You mean like Python style indentation blocking? If arg colon and then like do indentation, but that's white space sensitive, which is something that I personally don't like. There is a lot of people who don't like white space sensitive languages, me included. Although technically, like, why? Like, also, like, the semicolons, I guess. If you do white space sensitive, you can get rid of the semicolons, right? That's what Go does. Does this Harnet language do it too? Yeah, they don't have semicolons here. They still have brackets. They still have brackets, though. For some reason. Right? But they could get rid of it, too. I mean, that's just what Go is using too, right? Why does Go use this if it's already is white space sensitive? What's the reasoning behind that? Why Go uses brackets instead of just relying on indentation? Semicolons are in some interesting place right after if. Yeah, like, it's because everything is an expression, including the ifs. Like in Rust, there is actually, like, syntactically the difference, for example, between the if, which is a statement, and an if that is an expression, which is why in Rust you don't need to follow the if with a semicolon. For now, I don't do that. It is a little bit weird. It's not very like it's like I'm not used to this, right? Myself, but I don't know. I feel like it makes a lot of sense, and in terms of like making the language simple and not having like a lot of specific rules, it actually helps to keep the language simpler, right? Because like everything is treated the same. Why after some things I need semicolons and after some things I don't need semicolons, you know? Look or for look like function call. My function call looks like this over here. I don't even have parentheses there. So I have actually less parentheses than some languages, right? Although I'm not sure if I'm going to keep it like that. Maybe I will require parentheses for function calls. We'll see. Value. What is this? Evaluate native expression natives. Yeah. So over here we have find opt native expression by name value. So this is like function, and I want to basically call this function using expression type. So like this is the type that I expect. Yeah. There it is. Do you have tuples already? Yeah, I do. I mean, I've solved the advent of code with it, and I mean. That doesn't mean that I have tuples, I guess, necessarily. But, I mean, tuples is all that I have, technically. Tuples and variant types are the two main types that I have. So tuple is just the product type, and variant is the sum type, I guess. Right? I have tuples which are they defined with parentheses? No. They are defined with a comma. That's what defines a tuple. Here's my REPL, right? I can just say, well, I mean, I need to stash, I guess, here. A tuple is just a comma, so we just say 1 and 2, and this is the thing. You don't need the parentheses. Parentheses is just, once again, everything is an expression. Parentheses, all it's doing is it is, just like in math, is just changing the priorities of operations. That's all. It's just for fixing the priorities. Well, I mean, technically for me, the parentheses are they're also introducing the scope. So like if you have like the variables inside here, then like, you know, then this variable only exists inside of these parentheses. But yeah. It's like similar to Python, I guess, right? Where you can say like A and B is BA. By the way, I should fix this. I should fix that. I have to do comma assignee. Maybe I do that. Hold on. Let's do that real quick. Comma assignee. This is really easy. No, let's do polymorphic natives first. Looks like F# in some cases. Yeah, I mean, we have inspiration from a lot of different languages, I guess. A lot of languages. Git stash. All right. Maybe function. Maybe it should be polymorphic. You're back. Welcome back. I think native function should be the thing that like has type which is function No, it should not be function. It's just we have implementation which has implementation. Yeah, implementation. There you go. Implementation. But implementation should be implementation type v native function. Yeah, so this should be like function type into implementation type, like this. Where's this command coming from? Function type into that. Yeah, there you go. Okay, so native function, let's see. Let's ignore the types here, actually. Let's just say native function. Native function. So this is going to be function type. So this is going to be the type of the function. Right? Implement type. Special display of type string. Yeah, the string times the type into value, right? Like this. Native function type. Yeah, so this okay, that makes sense. Implementation type. This is going to be type. So type is a function type then. Type is inference. No. Type. Type is function type. Function type. Function type is types type function. Argument is type new not inferred. Result is type new not inferred. And then we say that type inference type expect inferred as type function type inferred span. Is that what I do? Types type function. There's a comma here, right? There's a syntax error somewhere, and once again I don't see it. Oh, this says impl is like that. Makes sense. So type in this case is a type function. That makes sense, right? And we can like assert the type here, like for example that it returns unit. But we can just ignore that for now. Char code function type from code function type. No, not here, over here. Function type. Function type. I wasn't even using that information like anyway, I guess, right? Yeah. So the type for the functions are going to be defined. Like I can like assert them here, but they are defined in the standard library anyway for the natives. So it's whatever. Um, String times type into value list, right? What we want here. String type. So yes, string to int32. This is the parsing, right? We can instead have a native function parse. And now, since we have the type information here, we can say let argument. We ignore the argument. We care about the result type here, right? Result type. Right, and what we return is going to be based on the result type, right? Type. So yeah, this is type function, right? So instead of having these three parsing functions, we're just going to have a single parsing function, but we're going to say that shape is, we're going to match parsed is, we're going to match result type await inferred. Thank you for coming, GJ. Good luck with your language too. See you. So I'm going to await inferred here, result type. So if the type that I want to parse is an integer, in this case, it's going to be int32 of string opt s into option, and then into option map the function x v int32x. Is there a way to do that thing shorter? This parsed, and I'm going to match parsed with some value, then we return value. Otherwise could not parse this as that. Type shape print type print result type. Do you plan to have natively curried functions? Probably not. Probably not. I'm not a big fan of currying. They're kind of like, it's kind of like necessary to use currying in OCaml and like these function languages, but I don't like it leads to very bad error messages in my opinion. And there are like other language mechanisms that currying is supposed to solve. I mean, yeah, I don't know. I don't like it, I think. So like I'm not having a functions or like normally in your function languages, if you have a function that takes multiple arguments, then it's a function returning a function, returning a function, returning a function, right? I instead just group all of my arguments into a single tuple. That's how I do functions with multiple arguments. That makes no more sense. You mean easy partial occupation? Yeah, I know what currying mean. Yes. Easy partial application. I don't know. How often is it needed? Like, I feel like it's not needed very often. Like, for example, over here, like, I say function x into like v in 32x, right? I mean, no, never mind. Like, let's just have a function that calls it. I guess it's okay. Like, I don't know. How often do you want your function to be partially applied? I feel like it's only like useful in functional languages for some reason, but what's the reason? The reason is the lack of non-functional features, I think. Like in Rust, you don't have the way to do easy partial application, and I don't miss it there. Right? Mm. Okay. Anyway, so we do something like this. Based on the result type, if we parse in 32, then we do this. If we parse in 64, then we do this. If we parse float, then we do that. Oh, this did not work. Anything else that we want to parse? Boolean. Bool. Is there a bool of string opt? No. Is there a bool? There's toString but not offstring. Okay, sure. Whatever. Good enough. Okay, native function beat type unary minus. Oh, this one didn't even have the correct type, lol. Yeah. Create context type. Panic. Types, plain types. Plain types. So this should be a string. Hold on. So like types file system. File system is also a native function. Yeah, so just types. I think just types is of the different thing. Right? Let's have the function concrete Concrete, sure. Concrete is function value into function type into value, right? That's what I want. So here when types, we say types map concrete. That doesn't work. Types. Let's just do it here then. Types is plain types. List map this. Inferred value. Yeah. Okay. Fine. Whatever. We get rid of that. Never mind. Types is there's going to be type into value right here, and this is also going to be type into value. And yeah, so this is going to be just function whatever, and this is just going to be function into native function. Type. Okay, I mean in this case, I guess it's going to be function type. But I need to do function type. So this over here is type function. Function type argument. Inference type expect inferred as t type inferred span, like that. That's what you want. Yeah, this is just type, right? That function type undo function type. That function type is type function is this. This is function type, type inference type expect inferred as type function type type inferred span. That's okay. Nice. Okay, success, but it's not going to work yet, I think. I mean, probably the REPL is going to work, right? Yeah, but if I say std use std prelude star, if I say parse 1 2 3, that is not going to work because no implementation of type. This place is not initialized. Oh, of type underscore. Yeah, if we say parse, then I just say what the type should be, right? So no native int to this, right? Native string into true. This is just native parse. There we go. This should be native parse, and this should be native parse, right? Yeah. There we go. I think that's all. Use as the prelude. This. There we go. There you go. Polymorphic natives. Okay, let's really quickly do the comma assignee. That would be really nice to like swap the things, I guess, right? Actually, will it be... Wait, is it even going to work? Holy, it's not going to work. Wait, does it work in Rust? It works in Rust, right? It probably it does. Wait, does it work in Rust? Wait, hold on. Does it work in Rust? I'm not sure even. They use that. That mode A is 1. Mode B is 2. AB is 3, 4. But you need to do parentheses here. Should work though, right? Yeah, this works. This works. But the problem is, if I say AB is B in A, so the reason it's, I think it's not going to work. Maybe GAB, right? So this is going to be installing OCaml right now. Since you were asking about partial application and carried functions, I thought you are functional programmer and who is doing OCaml. What is your language that you usually use? Or are you like a Haskell programmer? So A is 2 and 1, right? It has been swapped. This is what this is the behavior that I want to do. Although I will not require parentheses here. Okay, so we just need to do assignee. To do tuple assignee. TypeScript, C#, F#. Yeah, I guess F#. I feel like you don't need OCaml if you do F#. I mean, I did not do F# myself, but from what I heard, maybe like I should have written my language in F# because I like. Tell me about how good is the editor support for F#, because my language server is crashing sometimes, showing me bad errors. Like, and I have problems with recursive functors. Wait, do they have the functors, F# functors? Like, is it the same as the functor in module function? Like, you basically have different syntax for OCaml, as far as I understand. JetBrains writer is very stable. Yeah, I feel like you are going to have a lot worse experience in OCaml. From what I understand. F#. Do you have like generic module or whatever? Like, what do you call these things? Do you call it generic modules? Like, how do you create a map of a set of strings, for example? A generic class. I mean, yeah, that is this. Oh, wait, you have a class, so you have lets inside, right? Okay. This is actually, yeah, so like, this let z. Can you have a type inside here, though? Yeah, it's because like it's classes. Makes sense. Language reference. Let's see. Let bindings, functions, loops, conditionals, pattern matching, exceptions, types. Wait, do you have effects though? I guess maybe you don't have effects in F#. But there's probably something similar for the C# async code, right? Or do you have like async directly, for example? Reflection, interoperability, queries, organized code, modules. You also have namespaces, which is nice. Module. A module is a grouping of codes with various types and function types in F#. Is this the same as like OCaml module though? Module this is let. Namespace module name identifier. Nested modules. Can you have a function that returns a module? You have module rec, recursive modules. Notion or modules containing all code to be mutually recursive. Oh, this is different, right? This is code inside of the module is recursive. Okay. I see. Yeah, it's a little different, I guess. I feel like I don't know. Maybe I would like F sharp more. If I thought about it earlier. Yeah. Like, I understand that it's like because it's the .NET language. Yeah, that makes sense. I don't know. I mean, you should try OCaml. See if you like it. Um. Like the only thing that I'm wondering is F sharp async, I guess. Async programming in F sharp. The concept of async. So you like literally have the async keyword, right? Okay. Or is that not a keyword? Probably a keyword, right? It's not highlighted here. Maybe it's like a function that takes this. And you do async await task. So await is not a keyword, yeah. And this is the let. This is like the monadic let then. Computation expressions. Builder expression. Oh, okay. It's builder. So like, yeah, okay. So it's different monads, right? I guess is what this means. So you can have your own kind of a monad, and then inside you have lets, ends, do's, yields, and stuff. Okay, yeah, that makes sense. This is also nicer than OCaml, I suppose. Maybe. I feel like if I was starting from scratch, I would make my language in F sharp. But yeah, maybe I don't know enough about that language yet either. All right, what did I want to do? Comma assignee, right? So I want to have a new thing, a new assignee. Right now we can just do assignee to unit this, but I need to have an assignee of tuple of assignee expression tuple, right? And assignee expression tuple is we just have tuple. You can extend it with your own keywords. Oh, really? Do you have custom operators in F sharp? You should be able to, right? I mean, you can at least like overload the existing operators because yeah, that's possible in OCaml too. But you mean like every like exclamation mark is basically like anything before the exclamation mark in your own keyword, right? Yeah. Let this is some function. Yeah, that's the same in OCaml. Tuple. Tuple of assignee expressions. Right? That's what I need. Like this. Print when I'm printing assignee expression tuple. Tuple. Tuple print. Tuple. Print assignee expression. Okay. Do you have derivers in F sharp, like preprocessors which can format you, which can like process your code and generate some code? Or maybe you don't need that because you have a reflection and you do it at runtime instead. So when I'm performing the assignment, if I have an assignment tuple, then I'm assigning this to a place. Yeah, I need to like evaluate place. I need to evaluate the place. Wait, do I need to evaluate the place? Yes, I do need to evaluate the place. This is evaluate place into claim. Do I need to claim it? Claim value await inferred, and then I need to match this with this error shiny data span span expected tuple. I don't do anything here. And if it is a value tuple, C# has F# is limited with this. There's custom implementation of compiler services like Myriad. Okay. Yeah. I keep asking things and then I will want to actually write, but I'm so close to actually self-hosting. I don't think I'm going to go for F#. There's no way. Man, I'm dropping here. Tuple. I'm just going to rewrite the language in itself. But I will need to add the compiler written in OCaml, I guess, so that it's not super slow. So we just do this is tuple is assignee tuple, right? So what do I need to do? I need to do tuple zip assignee tuple and tuple, and then map function assignee field into tuple dot iterate, I guess. Maybe. Wait, do I not have the iterate? I don't have iterate. Let's add the iterate here. I have to sequence though. Yeah, I have to sequence. Tuple to sequence. Sequence iterate. Right. So we have it should be like member assignee and field like this, right? So assignee is the assignee and field is the value tuple field. tuple field. So inside here, evaluate place. As type place type place expression. Oh, I already have the place. I don't need to evaluate it, right? I just claim it immediately, right? Okay. Right, and then over here what we do is I'm just doing the assign span state assignee field dot place, right? There we go. Initialize. When I'm initializing the expression assignee tuple, and we'll have type inferred span the tuple name is optional name new not inferred span tuple is tuple map I function member. Hold on, it's like similar to expression tuple. Over here, I need this. We copied and put like here. It's just tuple field of expression tuple field of. Yeah, what is this function here? The function, I have labels here too, right? Type tuple field of. Okay, this is just should be assign expression assignee like this. So this should be expression assignee is field expression and stuff. Yeah. So assignee tuple should be not the assignee expression, should be assignee expression tuple field of, right? Is that what I want? Assignee. So when I print tuple, this should be okay. Expression tuple. Like that. I just print assignee expression. Okay, zip order. This is the actual assignment now. Assignee. So in this case, assignee is assignee dot field, right? Is that what I want? Just unbound record, of course. Let's say types. Assignee expression tuple field of, right? That's what you want? Okay, thank you. Okay, inject assigny bindings. We have assigny tuple. Then into tuple to sequence. Sequence, iterate, function, member. Member. Field. There's so much fun in OCaml, yeah. I don't like it. How do you do a function in F sharp? You just do the arrow and that's it, I'm assuming. Field is. Also, I'm wondering how does type inference work in F sharp, because that's like the fact that I'm annotating my type here is very annoying. I'm doing that all the time, even although it's supposed to be like easily inferable, because like I know the type here. So why do I need to repeat myself? It's because in OCaml the type is like when you try to have to access a field of a variable, it infers the type of the variable to be the last type that was defined in current scope, which has the field that you're trying to assign, that you are trying to access. Which I really don't like that. Function x, or just less x. So it's the same. It's the same in F sharp, literally. You still have fun. What's the reason for the fun keyword to be there? It tries to infer from usage. So it's the same in F sharp then. Yeah, I don't like that. Like, why does it try to infer it from usage? I want it to be inferred from, like, the other places. Literally any other place than the usage would be nicer, in my opinion. Yeah, that expression is literally the same as OCaml. The list mapping. But that doesn't have fields. That doesn't have fields. Oh, that's what I was talking about, the inference. Here's the example, right? Let me show you here. Like ID, for example, right? What's the function of this function, right? We have a function that generates. This function generates t in this case, right? T, type t. But why is this inferred to be t? Because this has field value, and the only type in the current scope that has the field value is t. Now this works for this simple case where we just have a single type in scope, right? But what if I have a different type, right? I have type foo here, which also has like value, which is also int, right? So this technically can be this technically can be the type foo here too, right? But it infers it to be t. Why? Well, that's because this is the last type that is inferred. So it depends on the order here, right? If I manually annotate this to be foo, then now it's it's inferred to be foo, though, which is why I'm always doing like annotations, which I feel like are really extra here. I would not mind the annotating this manually, right? But I mean, like I see why they did it, but I feel like it breaks in more complex examples, right? If I have a self-contained module like this, then it's nice, though. Yeah, it is inferring it, but like in my other places where I have like a lot of types and I have a lot of like types which have the fields with same name, right? I have an expression tuple, an assigny tuple, a pattern tuple, and stuff like that. And they all have the same fields. So I have to annotate because otherwise it infers the things to be incorrect. otherwise it infers incorrectly, because it infers based on the fields that are present. It does the same. Yeah, I hate it. I hate it. Like, because of that, I have like 100 times more annotations in my types than needed. Types dot. And then I always need to like remember it too, like how is this specific type. Assign expression. Tuple field of. Right, so I have the field and I have I just need to state inject pattern bindings. No, state inject assignee bindings only compiler. So this one must be recursive too now, right? Only compiler. Field dot field. Field underscore. Do that. Yeah, sure. Okay. LSP, we're almost done. LSP. In LSP, if I have tuple, then we need to do tuple copy paste from that place. So this is going to be a expression assignee, and we do assignee field assignee. Okay, and then the last error in the transpiler, of course, is not used. Assignee tuple fail with lock. Types. Okay, success. Let's see now if this works. So I expect this is not exactly going to work properly. So can I can say let A and B be 1 and 2. I could do that before already. So A and B is 1 and 2, right? But now we should be able to just say A and B is 3 and 4. To do comma assignee. Hold on. To do comma assignee. Okay. There's this to do. This should just do this should do assignee tuple. Tuple is tuple init assignee span C state. That's all. So if I say let AB be 1 2, AB be 3 4, AB is now 3 4. There you go. So this works. What is not going to work though, I think, is that AB is BA. So what is AB now? It's 4 3. Wait, hold on, it worked. Why did it work? Let me think about this. Let me think about this. Why did I expect this not to work? I did expect it not to work. It's because in my interpreter, when I'm doing assignment, you might check F# active patterns. There is no such feature in OCaml. F# active pattern. Is it a pattern matcher that has like some code, like a custom pattern matcher or something? Active patterns allow you to define named partitions and subdivide input data so that you can use these named pattern matching expressions as you would for a discriminate union. You can use active patterns to decompose data in customized manner for each partition. Let identifier arguments value to match is expression. This is the syntax. What is the example? As an example, consider the following active pattern with an argument: let, even, or odd Input is, if input is 2, then even, else odd, right? So we can match this with even and this, right? So even, so this is a named, like, yeah, I see. It's like, yeah. What I don't like though is, well, I mean, it depends on how do you match against the actual, like, variant. Match expressions, let me see. Like when you have an option, for example, an optional type, right? Like over here, yeah, right? You say just A, or B, right? And if A is like without of int, right? Just a union like this without the data, this will look like A, and this one is also will look like A. So it depends on what's in scope then, or something. Maybe it's not an issue in practice, but I feel like there is the same syntax. Well, I mean, yeah, I guess like when you define your like ADT, it's like pattern as a value, right? Kind of thing. So like syntactically, this looks like I'm trying to match the variant named even, but it's not, right? It's not a variant. It's like a custom active pattern. But maybe it's not a problem in practice. I don't know. Yeah, this is nice. Maybe we should have something like this in my language. Active patterns. Is there other languages with active patterns? Just F sharp is the first thing. Okay, why did I expect this not to work? AB is BA, so to swap. Why not? Well, the reason is because when I'm having the tuple, right? I'm doing the assignment. Here assign. So I know that on the right side we have B and A, which is a tuple. Oh, but this is a new tuple, I guess. Yeah, I guess it's because this is a new tuple. Yeah, never mind. This is all okay. I don't know. I don't know why I thought it should not work. It just works. Never seen in other languages. I think Python actually has like Python active patterns. They don't call it active patterns, right? But like, you know, Python pattern, structural pattern matching. I think you can like define your own custom pattern matchers, because I don't know. I don't remember how it's done. Can you have a custom pattern matcher in Python? Like, I'm pretty sure that I read something about that. So yeah, there is a match args. If you just want structural pattern matching, you recognize your own types, give a class match args, and do that. No, that's different. If you want something fancier, a custom destruction logic, you can override match args dynamically, or wrap your objects in so the matcher sees the fields automatically. Maybe not. I don't know. I don't remember. I don't remember what I read. Okay, anyway, as comma assignee. I mean tuple assignee expressions is what I just did. So we can actually swap like this, which is nice, right? This is nice. Yes, I agree. This is nice. By the way, one of the other things that I can do is, well, can I can do like this. Let x and b is 3 and 4, right? So x is the new variable, but b is the old variable that I had before, right? I don't know if that's needed, but we can do that. Tuple assignee expressions. Let's see. Cast restart language server. Is there anything that's not working? Std int to string. This is just to string, I guess. 2 plus 2 quote must be expression. Wait, quote must be expression. Oh, quote must be expression. Hold on, this doesn't work. I need this to work. For syntax, quote must be expression. If it's over here a place expression, then I need compiler temp expression module cast. Is that what I want? So that works. Let's ast be 2 plus 2 ast. There we go. Anything else that is broken? These errors are supposed to be here, and this is supposed to be here. Okay. Nice. Fix. AST as place expression. Let's just try cast examples, guess a number game. Let's see if this still works. For some reason, maybe it was broken. Looks like it is working still. Okay, what about random number generation? You know what? Let's do this. Let's take a look at RNG. RNG.ks over here, right? I have gen. We have gen int 32. What I want instead, how about this? We have let's make this a generic one. We can have const gen is just for t. We have minimum. Should be like gen range. Gen range. RNG gen range. So minimum is t, maximum is t. With RNG returns t. CFG if interpreter, then we do that. Yeah, I remove that. We don't have the dedicated one for int, and we can do that for other ones too, right? RNG. Native RNG dot gen range. Let's do that instead. So there's going to be RNG dot gen range. So I do want the type here. This is type function, right? Yeah. I'm actually pretty curious what algo you ended up using for day 9 part 2. I don't know if it has a name, but we just iterate. Well, first of all, we compress the coordinates, right? We compress the coordinates, which means that the coordinates are just at most 750. So if we just draw the thing on, like, if we draw the entire map, it's going to be just 1,000 by 1,000, like even less than that. So you can actually like do it like that, right? And then after that, like say that you fix one corner, then all that you need to do is you basically first you try to make a long horizontal line, right? And then you try to expand your so let's say that you fix the lower left corner of your rectangle, right? So first you just expand fully to the right, so just a strip of one tile high, right? So you expand as much as possible, and then you try to like expand it up. So every time you expand up one tile, you might need to shrink to the left based on if there is like empty tiles there or not, right? And that's it, I guess, right? So and then you also need to check that you don't hit anything by your ceiling, right? Which can be done quickly by using like prefix sumps, for example, right? So once you fix the corner, the solution is actually like of iterating the second corner is just linear over the size of like one size of the map, I guess, even. So yeah, the solution is technically just like quadratic over the amount of points in your polygon that is given. But because my interpreter is really slow and because I didn't have arrays, so I'm using trips for doing arrays, which is like logarithmic and stuff. Because of that, my solution was actually running for 20 minutes, but it's supposed to run in like less than a second in a properly compiled language. And also I used the fact that the input that is given is of specific shape, right? There is we generated this SVG, so this is what the input actually looks like. It's a circle with the thing deleted, so you don't even need to find the first corner. Like you don't need to like try each corner. You only need to try these two corners over here, because these are guaranteed. One of these is guaranteed to be the answer. You still here, Pigorli? I am still here. You think I should quit? Okay, fine, I'll quit Pigorli. If you say so, then I will end the stream. All right, since Pigorli said that, let's see who else is online. You will not allow it? No, but it's too late, Pigorli. It's too late. It's too late now. Well, I mean, I did a lot of things today. I solved the advent of code, which was like relatively difficult, and we improved the language. I just didn't implement the arrays. Advent of code with a new language every day. What language is it today? Okay. Thank you guys for watching. See you next time. Tomorrow. Wait, see you soon? Are they ending the stream? Hold on. Thanks for talking to me. No. What language is that? No idea. Alright, anyway. Bye.